Java has become a mainstay when it comes to the IT industry. Java's ability to call hardware and fuse software code with it is unmatched. From basic machinery like washing machines to complex systems such as supercomputers. With one of the lowest attrition rate, Java developers have continued to grow in their field and will continue to do so soon, making the current window a ripe time to learn Java. Hello everyone and welcome to SimpliCode's YouTube channel. I hope you guys are doing well. Today, we'll be taking you through the Java Basics full course. This Java for Beginners full course will cover all the basics of Java. In this video, you will see how and why Java is used today. By the end of this tutorial, you will be able to understand and deploy basic projects using Java. But before we begin, let me tell you guys that we have regular updates on programming videos. So, if you are a programmer and want to learn something new, then consider getting subscribed to our YouTube channel and press that bell icon to never miss any updates from SimpliCode. So, let's go through the agenda for this full course tutorial. We'll start this video with an introduction to Java, followed by installing Java and Eclipse on Windows 10. We'll move on and cover basic Java topics like data types, tokens, and data type conversion in Java. Once we finish with these basic Java topics, we'll go through our first Hello World program. Moving ahead, we'll cover topics like arrays and operators in Java. We'll then cover topics like conditional statements in Java and loops in Java. We'll go through all the different types of loops present in Java. Finally, we'll end this video by going through a mini project wherein we'll create a calculator with all that we have learned. I hope you guys are ready to learn something new. So without any further delay, let's get started.
When we talk about Java, it is one of the most popular programming language out there, and it was created way back in 1991, but it was publicly released only in 1995. It was developed by one of the famous developers of our generation, who is James Gosling at Sun Microsystems, and then later Java was acquired by Oracle, and today Oracle owns Java. Java is very simple and easy to use, and we will look at different aspects of how it is easy and simple to use. It's a write once, run anywhere type of programming language. Again, we will look at details into this particular concept as well. And when we talk about the usage of Java, you can use it to build web applications, mobile applications, desktop applications, even command line applications. And at the same time, you can also use it to build complex applications like gaming applications, building microservices, or building distributed computing, etc. Let's talk about the features of Java. So one of the most prominent features of Java is that it's an object-oriented programming language, which means that everything which happens in Java happens around objects. Objects enable the execution of the program. Objects talk to each other to exchange data and messages. We will look at the concept of objects in details in the upcoming lectures. It's a platform-independent language, which means that, again, going back to the previous point of write once, run anywhere, it basically enables the program to be run on any platform once compiled. So once you have prepared your program and you have compiled your program, then your compiled program can be run on any platform. It is a strong type checking language, which means that it will force you to respect the contracts of the variables to the data types. For example, if you have created a collection which should accept strings, then you can only insert strings in that collection, and it will not allow you to add a number or an integer into that collection. So it's a strongly type checking language. So when you run your program, it's a two-step process in Java. You compile the program and then you execute the program, which we also call as interpretation. So you have a Java compiler and you have a Java interpreter. You first compile your program and then you run the program using the help of Java interpreter. Java also provides automatic garbage collection. It's a really important feature. And if you talk about the languages prior to Java, like C or C++, they did not offer this capability. And this capability made Java really popular because it could automatically find the unused objects and variables and remove them from the memory to free up memory space for the program execution. It also provides multi-threading support. which means that you can build multi-threading applications like a gaming application. If you take the example of a racing game, for example, so there can be one thread which is monitoring your leaderboard score. There can be another thread which is displaying the speed of the car. There can be another thread which is displaying the graphic. There can be another thread which is displaying the sound. So you see all of these threads are working parallelly, and Java provides the support to create such applications using the multi-threading capability it has. Java is secure by default because there are no pointers in Java, so there are no possibilities of having any memory leaks or any reference leaks from the application. Again, if you take the example of programming languages like C or C++, you had the concept of pointers, and we witnessed a lot of scenarios and lot of incidents where there was a memory leakage happening in the production application, which was really a bad experience for the organizations. So Java removed the concept of pointers totally from its programming language. It's also a very robust language because it provides a really great exception handling framework out of the box, which developers can use and implement to build really resilient applications. So now let us understand how a Java program is run. So at first you basically write your Java program and you store your Java program into a .java file. Then you compile your Java file with the help of the Java compiler. Once the program is compiled, the compiler is going to generate another file which is a .class file. And this .class file is basically the compiled file, or also known as the bytecode file. So this bytecode or the .class file code can be run on any platform, be it a Linux platform or a Windows platform or a macOS platform or any other platform. To give you some more context, the first two steps where you write your Java program and you compile your Java program can be run on any machine. Let's take the example that you ran these two steps on a Windows machine. So you write your program and you compile your program on a Windows machine, which generated a .class file. Then you transported this .class file to a Linux machine and it also worked there. You transported your .class file to a macOS machine and it worked there as well. And that's what brings the platform independence concept of Java, that you can write the program once on any platform, and once you have the bytecode available, then you can run this program on any other platform of your choice. Okay, so that was about how the Java program execution works and how the platform independence is actually achieved. Now let us spend some time to understand the anatomy of Java. So once you download Java and install Java on your local machine, you will hear the term JDK. Actually, we'll see that in the next lecture, that when you try to download the Java, it will say JDK download. JDK stands for Java Development Kit. So the Java Development Kit is the installation of the Java. This is what you're going to install on your machine. Once the JDK or Java Development Kit has been installed, the JDK will provide a lot of other components as well, like Java Runtime Environment or JRE, Java Virtual Machine or JVM, some class libraries, and some other supporting libraries. So let us understand what happens when your program is run and how these components work together to make sure that your program runs as expected. Let's start from here. So you install JDK or the Java Development Kit, you write your program, and then you compile your program with the help of Java compiler, which is provided by JDK. Once the program is compiled, your .class file will be generated, and then you can run that .class file using JRE. In fact, if you just run your program on your local machine, JRE will automatically kick in and run your .class file. So the Java Runtime Environment or JRE runs your .class file with the help of these three components. Let's talk about first component, which is Java Virtual Machine or JVM. So the Java Virtual Machine is actually the virtual environment inside which your program runs. This is the real main environment inside your .class file is running. So when this program is running, how does it achieve this environment? For achieving this virtual machine environment, it would need some runtime libraries, and that is provided by these class libraries. For example, there would be a runtime jar or rt.jar as a shorthand, which will be supplied to the program at the runtime to make sure that the program runs smoothly. Then there are other supporting libraries as well which your program may be using. For example, if this program, this .class file is, let's say, a calculator program, then it might be using a square root function from java.math package. So how does the java.math package get supplied at runtime? It would be supplied by the other supporting libraries which are present inside JRE. So JRE will make sure that your program runs inside the Java virtual machine. It gets the required runtime libraries, and it also gets the libraries which are referred in your program at runtime. And this all together will make sure that your program is running. So you can see JDK basically provides JRE automatically and JVM automatically, but you can also install JRE separately. If you talk about that use case where you compile your program on a Windows machine using JDK, and then you exported your .class file to another machine, and there you just install the JRE. You don't install JDK there, you just install the runtime environment, and you can run the .class file just using the runtime environment. And let's type JDK Java download and hit enter. Then you need to find the link which says oracle.com, because like we discussed in the previous lecture, Java is owned by Oracle. So we need to download it from the official website only. So we can click on this link which says Java SE downloads. It will bring us to the downloads page, and we will see different versions of Java. You can see the Java SE 15, you can see Java SE 14, you can also see Java SE 11 and all the previous versions. Another thing which you will notice that it says LTS here, which means long-term support. Basically, long-term support are the releases for which Oracle is going to provide long-term security patches and updates. For the non-LTS releases, Java will not provide long-term support and long-term patch fixes and long-term security fixes. So it's a good idea to analyze and evaluate on which version you want to develop your applications on. For this demo, I think it is fine. We can go with the non-LTS version. And even for your customer-facing applications, you can start with the non-LTS version and then upgrade to the latest LTS version whenever that is available. So for this demo, we can download Java SE 15, and you can also do the same on your machine. It will work exactly the same way as an LTS works. So you can click on the JDK download option here. Let's click on that. It is going to bring up the downloads detail page, and you can see there are multiple options given here in terms of what platform you want to install Java on, whether it is a Linux platform or it is a Mac OS machine or it is a Windows platform. So like I said in the beginning of the demo, that today we are going to see how we can install this on a Windows machine. So I'm going to download the Windows x64 installer here. If you are working on a Linux machine or a Mac OS machine, you can download those respective installers as well. So you can see the exe here. So let's click on this. Once we click on this, we'll get this pop-up, which will ask us to accept the Oracle Technology Network License Agreement. So we can hit this checkbox and click on Download JDK 15. And this shall start the download, and you will see some exe getting downloaded in your download box here. But as the download is going to take some time, and I'm not going to wait for that, and that's the reason I have already downloaded the JDK 15 for this particular demo, and that JDK is sitting here on my desktop, which I've downloaded prior to this demo. So we'll just run this particular exe, which is exactly the same exe as the one which is being downloaded. So let us double click on this. It will ask you for this pop-up in some cases. So you can just hit yes. Basically, it is asking whether you trust this exe or not. But as we downloaded this from official Oracle website, then we can trust this particular exe. So I will hit yes. And now the installer is going to unpack, and you might get a screen like this, which will be an installation wizard for the Java SE Development Kit 15. Another thing which, before I proceed, I just wanted to highlight that as well, that you might have noticed the word JDK here. It's exactly the same term which we covered in the last lecture, that when you install Java, you basically install the JDK, which is the Java Development Kit. And this is also visible here when it says Java SE Development Kit 15. So let's hit next. Then on this particular page, you have the option to change the installation location of Java if you want to. By default, it is going to install in C program files /java/jdk15. But if you want to change the location and you want to install Java to a particular custom location of your choice, that is also possible. You just hit change here, and then you can choose whatever directory or folder or place you want to install this Java on, and you can basically select the appropriate location. For this particular case, I don't want to change that. I'm happy with the default location, which is available here. So I'm just going to proceed with this particular location here. So I will just hit next, and then Java is going to install, and it's very fast installation. It generally takes few seconds, as you will see in this demo. Basically, it is going to unpack all the libraries and all the runtime libraries and all the class path libraries which we discussed in the previous lecture, and put all that into the location which we specified to install Java. It will also set up the rest of the prerequisites which are required to run Java successfully. So looks like the Java has been successfully installed, as is visible in this message. And there's also a next step if you want to access the tutorials or the API documentations, the developer guides, the release notes, etc. I don't want to do that, so I will just hit close here. And now if we want to just verify if Java is installed or not, then we can verify that from the command line prompt. Let me just exit this, and let's go to the command prompt to verify to see if Java has been successfully installed. So to do that, we'll just open the search bar and we'll type cmd. It is going to show us this command prompt here. We'll click on this and it will open the command prompt for you like it has opened for me. And there you just need to type java -version and you hit enter. If you get a message like this, it means Java has been successfully installed. If you get a message saying that Java is not recognized as a command, it means that Java is still not successfully installed and something has gone wrong in your installation. And in that case, you might want to restart. You might want to go back and reinstall this Java exe again. So in this case, it looks like it has been successfully installed. And we can also get some interesting information from here. We can see which version of Java has been installed. It says Java version 15. We can also see that the JRE is also installed. The Java SE runtime environment, or JRE, is also installed. And we can also see that the JVM is also installed, which is Java Hotspot Server VM. VM means the virtual machine. So if I connect this back to the previous lecture, we can see that the Java JDK basically installed the JRE as well as the JVM as well. And the complete Java package has been successfully installed. Now we are ready to use Java, a Java program, and run Java programs on this machine. And at this step, I would like to conclude this lecture. In the next session, we will be discussing how we can install Eclipse, because that would be the natural next step for any Java developer, that they want to install Java and then they want to install Eclipse and start working. Open my web browser and type Eclipse, download, press enter. And then you need to find the link which says eclipse.org/downloads, which is the first link in my search results. You can also see it says Eclipse downloads, the Eclipse Foundation. And Eclipse Foundation is the organization which maintains the Eclipse installers. So we can click on this. Once we click on this, we will be redirected onto the Eclipse downloads page. And there again, you will see a bunch of options. You will see the default option highlighted, which would be the Eclipse installer for JRE, for Mac OS, Windows, and Linux. And then you have some other tool platforms option as well, like Eclipse G or Orion, which you might want to use for advanced cases. But for running Java applications, all you need is an Eclipse installer, which is coming from here. So based on your machine, Eclipse will automatically detect whether you want a 64-bit installer or a 32-bit installer. And you can just click on this particular link, which says download 64-bit here. So I'm just going to hit download 64-bit. It is going to open this particular screen where, based on your current location, Eclipse will suggest the nearest possible distribution mirror. Distribution mirror is basically a server which is present somewhere in this world, which contains this Eclipse installer exe. And Eclipse has created these servers all across the globes. These servers are basically called the mirrors. And based on your current location, which will be detected taken from your ISP, from the internet IP address from which you are accessing this particular website. So based on your ISP location, it is going to suggest you the nearest possible mirror location so that your download is the fastest. So in my case, the nearest location is Netherlands here, as you can see, and I get a download option. This is the file name, which says Eclipse installer JRE Windows 64.exe. And if you think that this mirror doesn't make sense, just click on this option, select another mirror, and then you can choose another mirror. But generally, it works really well. It works based on your IP location, and it's generally the download speed is pretty good based on the suggested mirror. So I'm not going to change the mirror location because I think this works fine for me. So, and I'm just going to click on this particular button, which is going to start the download of the Eclipse installer. So now I have hit the download button, and you can see right now an exe has begun to download. It is going to again take some time, and I have already downloaded this particular exe just to save us some time, and I'm going to use that exe to showcase how we can install it. Another thing just wanted to highlight is that Eclipse is an open source organization. It works on donations. So if you feel generous about it, and if you feel that Eclipse is doing really great work, you can also donate to it, which will show here. So we can move to the next step, which is about installing. So you can see here, I have an installer here, an exe file basically, which I have pre-downloaded to showcase this demo. I'm just going to double click on this, and it is going to unpack the installer. You can see this icon will be presented to you, which says Eclipse installer by Oomph. Oomph is basically the provider for this particular installer who manages the installer. And based on your computer's capacity and speed, it is going to take few seconds. And in the background, what it is doing is basically it is unpacking this installer and creating all the installation files which it needs to successfully install it on your computer. Once that is done, you will be presented with this kind of screen, and you will see that Eclipse provides multiple different kind of IDEs for different set of developer communities. You will see an option which says Eclipse IDE for Java developers. You will also see Eclipse IDE for enterprise Java developers. You will see the IDE for C++ and C developers, web and JavaScript, PHP, Eclipse committers who basically contribute to the Eclipse organization, or RCP, RAP, tester, scientific computing. There are tons of IDEs which Eclipse maintains. For our use case throughout this series, I think we will be focusing on this particular IDE, which says Eclipse IDE for enterprise Java developers. You can also use this particular IDE, but this is a very bare bone IDE with very limited set of integrations. Like it says, it includes a Java IDE, a Git client, an XML editor, a Maven plugin, and a Gradle plugin. But if you look at the enterprise, you will get more integrations. You can use this particular IDE to work on whatever you work here. So these all will work here. But in addition, you can also use this IDE to build a web application, build a web service, build a JPA application, data tools, Java server pages, faces, etc. So this is more advanced, I would say. And we will go with this particular IDE. And you can also choose this IDE if you want to, but for this demo, we are going to choose this one. I will click on this. Then it is going to show me which virtual machine it is going to use. So if you remember in the previous lecture, we installed Java 15. It has automatically detected that location by reading my C program files folder, and it has automatically taken that. If you have multiple JDK installations on your machine, you can click on this icon and change a different Java virtual machine. I'm going to leave it as is. Again, the installation folder is also by default taken to your C users username /eclipse/ the JEE version number. And again, if you want to change this, you can also change a different installation folder. I'm going to leave everything as default. It will automatically create a start menu entry and a desktop shortcut. And now I hit install. It might come ask you for a user agreement. So you can hit accept now. And now it has begun the installation. The installation generally takes a bit of time to complete in some cases. So again, it depends upon your computer's capacity and speed. Basically, if it's a good robust machine with good capacity, the installation might be very fast, as you can see in my computer. And if you have a computer which is not very strong on configurations, you can just be patient and wait for some time, and the installation will be finished. Once the installation is finished, you will see this launch option here. You will also have an option to keep an installer if you want to, show the README file, but I think the main option here which we are going to use is the launch option. So if you hit the launch option, now the actual IDE is going to start up. It's again going to set up some configuration files and some bootstrap configuration files which it needs to, and then it will ask you to choose a workspace. Again, workspace is up to you. Where you want to create your workspace? The workspace is basically the location where you will create your projects. It will store those project files and the source code of those projects. So it is up to you where you want to create it. Again, I'm going to leave it as default here, but if you want to change it, just hit browse here and choose whatever location you want to. You can see, you can go to PC and you can choose whatever location you want to. I'm going to leave it as is. And you also have a choice that you don't want Eclipse to ask this every time. So you can check this box, and next time Eclipse is not going to ask you to choose a directory as workspace. And every time you start Eclipse, it will automatically go to this particular directory. So you can either check it or uncheck it based on your convenience and hit launch. Once you hit launch, it is going to start the actual IDE as a desktop application, and you will get a nice interface and a welcome screen from Eclipse, which will basically show the basic overview of the screen, something like this. So now you can see that the Eclipse IDE has started. It has a welcome page, which has multiple options. You can check out a project from Git. You can import an existing project. You can go to the marketplace, create a Java web project or whatever, or you can just close this. You have a nice navigation project explorer bar here. So all the projects which you're going to create will be listed here. There are also some quick shortcuts here for creating different kind of projects. And if you don't want to use that, just go to File, New, and choose a kind of project you want to create, whether it is a Maven project or enterprise application project or dynamic web project or just a project. If you just hit just a project, you can choose a basic Java project to start with, click Next, give a project name. Let's call it test demo. You can choose an execution environment here, the JRE, and currently this particular IDE has support up to 14, but I think this is going to work fine. We don't need to worry about it. We can also use a project specific JRE, like in this case, Java 15, which is the current installation. So I can use this option because I want to use Java 15 environment because I have Java 15 installed. So you can basically choose whatever option you want to choose. It gives you a flexibility in terms of choosing the JRE, whether you want to choose an external JRE, whether you want to choose a project specific JRE, or you want to use the default GRE JDK installation. So you can use this option as well if you want to. Project layout is either you want to create separate folders for source and classes, or you want to create the use the project folder. Again, these are just basic configurations which you can play around with if you want to. I'm just going to leave it as is and hit next. And then it is going to just give me a review screen here. If I want to change anything, I can. Otherwise, I can just hit finish. I can create a module name here if I want to, but I don't want to create it. So I just hit on don't create and open the Java perspective. And that's it. You have a Java project here where you can create your Java files under this SRC, and you can start executing those files. We will look out on those details in the upcoming lectures. But for this lecture, I think this is what we wanted to achieve. We wanted to show how we can install Eclipse and how we can create a very sample Java CLI project. And just type Java primitive data types. And if you hit enter, the first link which you will be given is this particular link, and this is the same link which I have opened. So let's learn about the data types now. So Java has these primitive data types, which you can see here. Some of them store numbers, some of them store Boolean values, and some of them store characters. So the data types which store numbers are byte, short, int, long, float, and double. These 6 data types basically are used to store any kind of numeric value. Let's understand these a bit more. Byte is the shortest possible data type value which you can use in Java to store numbers. You can only store numbers within the range of -128 to +127. So you can see the range is very small, and Java has created this variable for use cases where you want to store numbers which have very small value in this range. Why do we provide these kind of options? Just to save memory, because the smaller data type will require less memory to be used in the Java program. Similarly, the next bigger data type is short, which is a bit bigger than byte. And the range of this particular data type variables will range from -32678 to 32767. So that is the range for this particular variable. And you can see that it has a very big range as compared to the byte data type. So if you want to store values which lie in this range, you can use short. The next one is int data type. You can use this one to store even larger values, which range from minus 2 raised to power 31 to plus 2 raised to power 31 minus 1. The next one is long, which is even bigger than int, and it can be used to store the values within the range of minus 2 raised to power 63 to plus 2 raised to power 63 minus 1. So as you can see, as we go from top to bottom, from byte to long, the size of the value which can be stored using this data type increases. And that's how you will basically take a decision of whether you want to use byte or you want to use short or int or long based on what size of the value that variable is going to contain. Then the next ones are float and double. These two have been created for the use cases where you want to store the values, numeric values, which have decimals, which are precision values. I should also mention that byte, short, int, and long are only used for storing absolute numbers which do not have any decimal representation. Even if you try to store a decimal value in these variables, they will automatically be trimmed. The decimal values will automatically be removed, and you will only be shown the absolute values. And in case of float and double, they can maintain those precision and decimal values. So we use float for the use cases where you want to store decimal representations of the values. And you can see that the float value can store a smaller precision value, but double can store even a bigger precision value. So if you have really big precision values to be maintained, very big decimal values to be maintained, you should use double. And the float is used for storing a bit smaller size of the precision values. I mean, its range of values basically beyond the scope of this discussion. If you want to read more about this, you can go to these particular links, which will explain this in detail. But the basic idea is that float is good for storing two precision values. And if you want to go beyond that, you want to use double. In some cases, some people also use float to store even beyond two values as well. So it completely depends. The decision factor is how long the value you are going to store in the decimal. And that will decide whether you want to use float or double. The next one is Boolean, which is used for storing the Boolean values. Boolean values can be either true or false. So there are only two possible values. And then we have char, which is used for storing characters. It is using 16-bit to store the value. And this is a very popular Java question for beginner level programmers, that why does it need 16-bit to store the character? It's because it stores a Unicode representation. Unicode representation is the representation which can be accepted across platforms across the world in different character encodings. So let's move on to Eclipse now, where I have prepared a very short and simple demo. I'm just creating a variable for each data type and I'm printing them. You also see some things here like these keywords, and don't worry about these keywords. I will cover these keywords in detail in the upcoming lectures. You also see this, and you can just, for now, you can remember that system.out.println is used for printing anything in Java. Anything you want to print on the console, you would be using system.out.println. What is system, what is out, and what is println? Again, we will cover these in the upcoming lectures. For now, I'm just creating a bunch of data types here, variables here basically. I'm creating a char type variable, a byte type variable, a short type variable, an int type variable, a float type variable, a double, and a Boolean. The way you create variables is basically you put the data type name, you put the variable name, which can be anything, you put an equal sign, and you put the value, actual value which this variable is going to store. And I've done the similar thing for all of these variables. Java wants semicolons to be there when you write your statements. So please remember that your statements always end with semicolons. So I've declared all of these variables here, a byte, a short, an int, float, double, and Boolean. And then I'm printing all of them basically. Here I'm printing the char variable. Here I'm printing the byte variable. Here I'm printing the short, and so on and so forth. So how do we actually run this application or this program? You just double click on this or right click on this. You go to this run as option. You see this run as Java application option. So you can hit this option. It will run the application and it will present all the output here in the console tab. Let me just bring this up. So you can see all the variables have been printed here, and this is coming from these print statements. Like I said, this is used system.out.println is used to basically print anything, and I've used that to print all the variables here. First, I'm printing the char variable whose value is a. Then I'm using the byte variable, which is denoted by b and whose value is 2. So you can see the value is 2 here. Then I'm printing the third variable, which is c, which is a short type variable, which has a value 22. You can see short, and this is coming here. The next print statement is int. So you can see int here with the value 45, and this value is coming from here. Then we have float. You can see the float value being printed here, and you can see the float value declared here. You also see an F here, and this is the standard naming convention which Java proposes, that whenever you declare float and double, you end them with F or D based on whether it is float or it is double. Then you see the double value, which is having a bigger precision than float. So I've printed the double value using this particular print statement, which is printed here. And then we have the Boolean value, which is stored as G, and the value of G is true, and the same value is printed here. So whatever I write here basically is printed here. This is just a placeholder, and this is the actual value. So you can see that we are able to use all the variables here, all the primitive variables basically, which range from byte, character, byte, short, int, float, double, and Boolean. And that's it for this session. In the next session, we will be discussing about the non-primitive data types in Java, string data type and array data type. And like I said, for classes, we have a dedicated lecture upcoming. So don't worry about that. And again, for this particular case as well, I have already prepared a demo for this, and we'll basically do some look at some hands-on examples to see how do we create these variables, what does these variables mean. And the first non-primitive data type we are going to talk about is string. And before I go on further, I should also mention that it's very debatable in the Java community to call string as a non-primitive data type. And actually, technically speaking, string is a special data type. It neither fully lies in the primitive category, nor it fully lies in the non-primitive categories. I'm covering this as a non-primitive data type because it's a bit inclined towards the non-primitive category. Why do we do this? Is because Java does provide native support for string handling in the JDK. And that's the reason some of the developers feel that string is a primitive data type, which is primitively supported by Java. But at the same time, string is so customizable and it's so special in nature. It's the way it stores the value, the way it provides the operations and handlings. It's so different than primitive data types that it cannot fully be put in the same bucket as the primitive data types. So that's why I said it's a special data type, a bit inclined towards the non-primitive category. So what is string basically? We covered about the char data type in the previous lecture, and in char data type, you can only store a single character, right? But if you want to store a complete name of somebody, then it's a list of characters. It's basically a lot of characters together. Then in that case, you would need a data type to store that continuous sequence of characters. And that's what string does. String can store a continuous sequence of characters. Technically, string is basically a character array. You can call string as a character array. And don't worry if you don't understand about the word array. I will explain that in the same lecture. So basically, it stores the continuous sequence of characters. That's how we define string. And you see this string. This is basically the keyword, the data type basically in Java. So whenever you want to create a string, you need to write string with S capital. You need to give a name to the string. This can be anything. And then you can provide the value, which this particular string is going to contain. So you can see this is a continuous sequence of characters. T, E, S, T are the 4 characters which this string is going to contain. And after that, again, I'm printing this particular value. And like I said, don't worry about this. We'll cover this when we'll write our first program in Java. So this is just to print the string value. I'm just putting a string placeholder here, and then I'm actually printing the values of the string variable. Now, string can be created in multiple ways in Java. This is one way of creating it. There's another way of creating a string variable, which is this one, which says, again, the string data type, some variable name, a keyword called new. Again, don't worry about what is this new keyword. We'll cover this when we'll talk about running our first program in Java and writing the first program from scratch. Then we again say string, and then we provide the value. So if I compare this line number 4 to line number 7, you can see the difference is that I'm still storing the same value, test, but the difference is that here there is no new string keyword, but here we have this new string keyword. So what is the difference? The difference is this, that in this case, in this particular case, string is going to reuse the same object multiple times. But in this case, every time you call this, it is going to create a new object. Again, what is object? It's just, you can think of it as, for now, you can think of it as a memory block. We'll again cover objects in details. But these are two different ways in which you can create string. This is generally the most popular way of doing it because this is memory efficient, because you can reuse the same variable again and again. So I'm creating the string variable here and creating another string variable str1 here and printing both of them. Then I've created this strange looking thing here, which is basically an array. Array, like I said, is also a non-primitive data type in Java, and array can store a continuous sequence of anything. That anything can be a number, that anything can be characters, that anything can be a floating number as well. So basic idea is that if you want to store a collection or a sequence of multiple values, how do you do that? You do that with the help of arrays. Array is a data structure, a non-primitive data structure in Java, which can store lot of values of similar type. We also call it as homogeneous data structure, because it can only store same data type values or homogeneous data type values. So the biggest way to identify array is this square bracket. Whenever you see this square bracket in Java, it means it's an array variable. So here I am creating an integer array variable with the name ARR. This is the name of this particular array. It is only going to store integer values because I've specified int. And the moment I provide the square brackets, it means that it is an array. So you can declare an array like this, and then you need to assign a size to the array. Size is basically denoting how many values this data structure is going to store. So I'm saying new, again, it's a keyword, and I'm saying that, okay, create a memory block for storing 2 integers. So this particular array ARR can store at max 2 values at continuous locations. The next thing about array is that it stores the value in a 0 index based location. So like I said, it can store 2 values. So the first location will always be array of 0. And this is how you specify the location or index of the element which is going to be stored. So at the 0th location of this array, I'm storing 0. The first location of the array, I'm storing 1. And this is just to show an error scenario, but I will just comment this for now. You can just put double slashes and comment any line. So I'm just storing, filling up this array for 2 values, and the 2 values location would be 0 index and first index. These are just continuous memory locations, and we denote those memory locations as 0 and 1. Array indexes always start with 0, and I'm just putting some values here. You can put any values. And then I'm printing the whole array, and I'm also printing the first value of the array. And we'll see how this pans out, and we'll also see how we can change this. So now we are going to run this application. So I'll just go to run as and click on run as Java application. And once I hit that, I get this output here. So let's understand this output. The first one is I'm just printing the string, which has the value test. And you can see it has printed here. It is coming from this line. Then the next line which is printed is line number 8, where I'm saying another string str1, and str1 also had the same value. So you can see another string has the same value. And then I have printed the array here, the complete array. And you see this strange value here. It also tells us that if you want to print the array, then you cannot just put the variable name and print it. The reason is because this is a non-primitive data type. And once you do this, it is basically printing the memory footprint of this array, the whole memory location where this array is stored. That's why you see this strange looking number, which is the memory hash code. And if you want to print any particular value, or any particular element inside this array, then you can do that by providing the index location of that element. So here I've said that print the 0th location element of the array. The 0th location array element of the array was 0. So you can see the value 0 here. Let me put some other value just for fun and show you how this works. So I've just changed the values, and now let's see what do we get for array 0. We can see now I get value 3 because now at the 0th location, the 3 value is being stored, and that is what is being printed here. We can also print the first value. I'll just go run as Java application. You can see now the array of first index is being stored, which is basically technically the second element of the array. But because array always works on a 0 index based value format, that's why when we say array 1, the second element is printed. When I say array 0, the first element is printed. So always remember that array is a 0 index based collection or data structure basically. What happens if I do this? Now there is no third element in this array because the array has the size only of 2 elements. And when I say ARR of 2, which means I'm trying to print the third element in this array, which does not exist. So let's see what happens in that case. I get an exception. Exception is basically an error. I get an error saying that index 2 is out of bounds for length 2. It means that the array length was actually 2 and index 2 does not exist. Remember, it's saying index 2, not the element 2. Index 2 doesn't exist because only index 0 and index 1 exist. This makes 2 elements and the actual size is also 2. It does not have capacity to store third element. It does not have third element location anywhere. That's why it complains that you are trying to print a non-existing value. So this is where I would like to conclude my lecture about the non-primitive data types. So we covered about string, we covered arrays, and like I said, we'll cover classes in the upcoming lecture as well. In the next session, we are going to talk about tokens in Java. These tokens are broadly divided into 5 different categories. These categories are keywords, identifiers, constants, special symbols, and operators. So let's talk about each of them one by one. So when we talk about keywords, these are the words which are reserved by Java and they have a predefined meaning. You might have already seen some of these reserved keywords. For example, we have used int when we were working on the primitive data type lecture. We have seen this as well, though we haven't actually found out the meaning of this, but we will find out the meaning of this in the coming lectures. So don't worry about that. We have seen Boolean as a data type again. We have seen byte. So these Boolean, byte, int, class, char, catch, super, switch, synchronized, all the keywords which you see here, these keywords have a predefined meaning in Java. And you use these keywords so that you want to take an action, an expected action by Java. For example, if you call something as int, then you want Java to treat it as int. Int will only have a single meaning in Java, and there is no other meaning of int in a Java program. So that's the intent with the keywords. These are reserved words which have a predefined meaning. And we will cover these keywords at length during this whole course. The next token is identifier. An identifier is nothing but just a variable name, technically. And we have already covered this kind of identifier when we were showing the demonstrations for primitive data types and non-primitive data types, etc. It's basically anything which you declare as a variable is an identifier. And when you declare the variable name, again Java puts some sort of restrictions as to what you can or cannot do when you work with Java and you declare the variable names. For example, these variable names cannot start with numbers. So you cannot have a variable name which starts with any number. You cannot have a variable name which contains spaces in between them. You either have to fill those if there's a variable name which you think has 2 parts, for example student name, then you need to write it as student underscore name so that you can create the variable name with the same impact and still does not contain space. So spaces will not be allowed when you create the variable names. Similarly, you cannot have plus, hyphen, and ampersand in the variable names as well. These are the restrictions which Java puts on the identifier tokens whenever you create identifiers. The next one is constants, and we will cover these constants in detail in the coming lectures as well. But to give you an idea of what constants are, So constants are basically exactly what they sound like. They are the identifiers which you have declared in your program whose value cannot be changed once defined. So if you write something as final int I equal to 5, then this value is fixed. You cannot change the value of I again in the program. Java will not allow you to change the value of I again because I has now become a constant because you have put a final keyword in front of it. And again, final is a keyword, you see, final is a keyword basically. So these constants are treated specially by Java, that Java will make sure that their values will never change during the course of the execution of the program. These can come really handy when you have situations where you do not want the certain variables values to be modified. For example, if you have an application where you are counting the number of applicants, and if you have declared the number of applicants as final, then every time you call the application, you can do a +1 to the previous value. The value will not be reinitiated. So it is very useful concept, and it can be very handy in programs where you don't want to change the values. The next is special symbols. These special symbols are the symbols which again have a predefined meaning in Java. We have already seen this square bracket symbol in our previous lecture when we were creating arrays. So whenever you use these square brackets, then Java would understand that you are trying to either access or create an array, or you are trying to access or create a list, etc. So this is predefined. You cannot use this anywhere else or with any other meaning. Similarly, when we talk about these braces, these standard brackets or standard braces, these again have a predefined meaning in Java. Generally, whenever you will write functions and methods in Java, you will use these brackets to define the parameters of the function. Now, you cannot use these brackets in any other meaning in Java. Java will not allow you to use this anywhere else apart from using it in method parameters. Similarly, the next one is the curly braces, and the curly braces are used to define a code block in Java. You might have already noticed that when we were looking at the previous demos, you could see some curly braces, then some code, and then the curly braces would end. For example, if I show you here, it's just a sample example, and let me open the example which we covered in the last lecture. So you can see this curly brace here, and this curly brace ends here, right? So this defines a code block in Java. Any code block which you want Java to understand will always be starting with a curly braces and ending with a curly brace. Remember I talked about the standard braces. You can see these are the standard braces, opening and ending, and this is where we are defining this particular method's arguments. Now what is method, what is argument? Don't worry about that. We will cover in detail, but just an introductory concept. Whenever you are trying to define a method and you want to pass any argument to the method, you use these brackets to do that. Okay. Similarly, this is semicolon is used to close any Java statement. So you will see this semicolon here. Every Java statement has to have a semicolon as ending, otherwise Java will complain that it is a syntactical error. So it is part of the syntax. You need to put the semicolon, and semicolon has only one meaning in Java, which is that your statement is actually ending. Then we have star, and star is used for multiplication, and then we have equality, which is used for assigning any values. And again, assigning any values is everywhere. You are seeing this equality sign everywhere. So these are all tokens basically. The last type of token we have is operators, and we will cover these operators in the upcoming lectures in detail with the examples. But these operators are basically some special symbols, like for arithmetic it would be plus, minus, multiplication, divide. For comparison, it will be greater than, less than. For logical, it would be ampersand and pipe operators. Bitwise again will have some bitwise operators. So these are basically different categories of operators, and under each category of operators, there are certain symbols. Like for arithmetic, we have plus, minus. We have for comparison, we have greater than, less than, etc. So these again symbols are also reserved by Java under the operators tokens category. You cannot use these in any other meaning or in any other way. And like I said, we will look at a detailed example of this as well in the coming lectures. So this was a quick overview of what are different types of tokens in Java. So we have keywords, we have identifiers, constants, special symbols, and operators. So this is it. This is all what I wanted to cover in today's lecture. And in the next session, we will be looking at data type conversions. So when we talk about data type conversion, the whole idea is to basically answer the question that whether I can convert a int data type variable into a long data type variable or a long data type variable to a float data type variable, and also vice versa. Can I go back? Can I convert a float variable into a long variable or an int variable and vice versa? So this lecture is about answering all of those questions. And we will basically look at some examples to understand how the conversion works. But let me just explain the basic principle. The basic principle is that smaller box can fit into larger box. But if we have to fit a larger box into a smaller box, you need to do something else. So what do we mean by smaller box and larger box here? The smaller box is a variable or a data type which has a smaller range. If you remember, we talked about the range of short, byte, int, etc. And we could see that as we go from short to byte to int to long to float to double, the ranges were increasing, right? So we will follow the same kind of analogy that if we have to store a smaller range variable into a larger range variable, Java will automatically do that. But if I have to store a larger range variable into a smaller range variable, then I have to sacrifice some quality of the value. And we will look at the examples of that as well. So let's first look at the example where we can store a smaller range variable into a larger range variable. We call this as implicit data type conversion. So here you can see I have declared an int variable with the value 100 and I'm printing the int variable. Then I have declared a long variable, and what I'm doing that I'm assigning the value of int a to the long variable b. So I'm not assigning a new value to this long variable, but rather I'm just passing on the existing integer value into a variable of type long. Similarly, after that, I am taking the value of this variable of long type and storing this value into a float type. So you can see int is basically smaller than long, and long has a smaller range than float. So I'm just storing a smaller range variable into a larger range, and then a larger range variable into the largest range. And then I'm printing all the variables values to see if this actually is working. Can long automatically store the value of a, and can float automatically store the value of b? Here I'm just printing the variables, and again using the concept of the previous lecture, this is just to print the values, and I will cover this in detail in the next lectures of how this works. But here you can understand that we can use system.out.println to basically print the values. And here I'm just printing a string and then the value, then again the string and the value, and here also the string and the value. So this is what is happening in this program. And again, don't worry about these details. I will cover about what these concepts are in the upcoming lectures. So let's run this and see if the data type conversion actually works. So I will just right click and do run as and go to Java application. And if I click on this, I get this output. So the first output is pretty straightforward. I'm just printing the int variable as is. So this works. Then I am storing the int into a long and printing the long representation of a, which is b basically. And this also works without any errors or any warnings by Java. Similarly, when I talk about storing the long variable into a float variable c, this also works. But here you see an additional decimal precision here, because as we remember from the previous sessions, float is used to store values which have decimals or which have precisions. So it will automatically convert your absolute number into a number which has decimals whenever you try to cast this into float. Casting is also a word which is used. Some people call it as implicit data type conversion. Some people call it as implicit data type casting. So if you hear the word data type casting or implicit data type casting, you can think that it is exactly the same concept as data type conversion. So this is about implicit data type conversion. Now let's look at an example of explicit data type conversion. How does that work? So using the same analogy of the boxes, now I will try to store a larger ranging value variable into a smaller range variable and see how that looks like. So I will start with the largest, which is double variable. So I have created a double variable, and as we know that double is a variable which is used to store decimal values. So I'm storing this value here, and then I'm just printing the double representation as is without any changes. Then I'm trying to store this variable's value into a float variable. So I'm trying to go to a smaller box now. I'm trying to grow from double to float. And if you remember, I told you that if you have to do that, it will not work out of the box, but you have to do a bit something special as well. And this is the special part. This is called typecasting. Typecasting is basically a way to tell Java to explicitly cast this variable's value into this data type's variable's value. And you always need to do this whenever there is no implicit casting happening. If you are trying to store a larger value variable into a smaller value variable, you have to do this, otherwise Java will complain. You will get a compilation error. So that's what I'm doing. I'm telling Java to store the value of A as a float and store the value in F. And this is where I'm telling to store the value as float. So you just put brackets and you define float. And then I'm printing the float representation. Similarly, in the next one, I am trying to store the value of this double variable into a long. So you can see now I'm trying to go even from a precision data type to a non-precision data type, because long does not understand decimal values. So I'm trying to store a variable which has decimal values into a variable data type which does not understand decimal values. And we will see how the output looks like. But here also you need to do the explicit casting. Explicitly, you need to tell which data type this A needs to be converted into. That's what I do here, and then I print the long variable here. And then next, I will again go down further and I will try to store a larger long variable type into a smaller int variable type. So again, I'm trying to store the value of B into a smaller data type which is integer, and I'm naming the variable as C. Here again, I have to do this explicit casting. I'm telling Java to explicitly cast the value of B, which is a long data type variable, into an integer C, which is an int data type variable. And then I'm just printing the value. So this is what is happening in this program, that from double to float to long to int. Now let's run this program and see what happens. So I will right click and go to run as and choose the Java application option. And this is the output I get. First of all, for the double representation, the value gets printed, 0 is ignored. Then in the float, it works fine as well without any precision loss, because float can also print values up to 1 to 2 decimal points without any problems, even beyond that actually. So it works fine. Then when we talk about the long representation, we are trying to convert a double variable into a long variable, and we see that the decimal values are lost. This is expected because long does not understand decimal values. That's why anything after the decimal, or in fact the whole decimal portion, is gone when you're trying to store double or float into some absolute data type variables like int or long. And then in int representation, since you already have this long can easily be casted to int by just providing this explicit casting, and the int representation also prints 50. So we started from this value and we ended up with these values when we try to store them as long or int. So this is all I wanted to cover in today's lecture. So we covered basically about the data type conversion or data type casting concepts. How does implicit data type casting works and how does explicit data type casting works. And as we know the concept, the basic concept is that the value can easily be casted from a smaller range to a larger range without any changes or without any extra code. But when you have to go from a larger value to a smaller value, you have to provide these casting instructions to Java to successfully cast those variables. So that's all for today's session. And in the next session, we will be looking at how we can write the first Hello World program in Java. And there we will actually cover all these things which I have been saying that we will cover. So we will cover all these ways of how we can write the first Hello World program in Java. So as we have already covered how you can install Eclipse and how you can create a sample Java project in Eclipse, if you haven't seen that, please go back to my previous videos where you can actually see that. And once you have created your Java project, so your Java project might look like something like this. You will have an src folder here, So, and under the src folder, you see some namespaces sort of things created here, right? We call these as packages. And in Java, you can think of package as something which can group multiple related artifacts together. This is simply a grouping mechanism, I can say. It's a way to put all the related artifacts to a particular business problem into a certain place. For example, if you are working in an e-commerce application, so you might have created multiple Java files for let's say for checkout, and then some more Java files for the filters flow, I would say, then some other Java files for designing the advertisements. So you have multiple Java files, and these Java files now belong to these three different domains. So you want to group them together for easy accessibility, for referencing each other files within the code. So if you want to achieve that kind of flexibility, you would group the checkout code files into a single package. You can name it as checkout package. Then you can similarly do the same thing for the advertisement package and for the filters package. So similarly, I have created some packages here, which you can see. You see a package here which says IO GitHub Vikesh Pandey Hello World. And how do you create a package? You just right click on this. So you go to the src and you right click, you go to new, and here you will see this option which says package. So you can just click on this and write anything which you want as the package name. Let's call it as test package. It says invalid because the package is a keyword, so it is not allowing me to put package here, but let's call it test package 1, and you can just click finish and you will see a test package popping up here. Then you can right click on this again, go to new, and then you can create a Java class. Now what is a Java class? A class is basically a blueprint for an object. It's basically the specifications of an object. Like I covered in the very first lecture, everything in Java is an object, or most of the things in Java are object, I would say. So object is basically an instance of the class. So let's say you create a class for, if I take the same example of e-commerce, you create a class for writing the business logic of checkout, and then you create instance of this particular class to work for a particular customer order. So class is basically a blueprint. It's the specification, it's the skeleton of the object. So once you click on this, you can create a class. Now Eclipse is a pretty smart IDE. It will provide you with bunch of options on how you actually can create a class, and it will also provide you with some sensible defaults. For example, it will automatically select a source folder in your project which you have created. It will automatically select a package. In fact, the currently selected package. And if you want to change the package, just hit browse and choose any other package which you want to choose. So your class file will be created in that package. Then you can provide a name to the class. So let's call it as test hello world. And you can see I have followed a sort of a naming convention here. The first character I've kept it as capital, and then any other new word which is coming in my class file name is also capitalized. So Java would expect you and it would encourage you to follow this naming convention, that whenever you are creating a class, always start with a capital letter, then small letters, and every new word you are writing can start with a capital letter again. Java will not throw an error if you don't do this H capital or W capital, but it's a good practice. The next thing is the modifier. We are going to cover the modifiers in details in the upcoming lectures, but for now you can understand that anything which is marked as public is accessible to every other Java class in this whole project. That's the basic meaning of making a class as public. Public, as the name suggests itself, it means it's visible to everyone. You can select a superclass, and again we'll talk about the superclass later, but this is the Java lang object is the superclass of all the classes which are created in Java. Again, interface is again an advanced concept, and there are some other interesting defaults it provides. For example, if you want to create a main method. Now what is a main method? We'll just cover it in a while. So I will not do that. I will leave everything as default and I will click on finish. So I have this new file coming up here, and you can see it has automatically picked up the package which I selected, and it has also written public class test hello world with a starting and ending curly braces. In the previous lecture, we covered about these curly braces, that all the code block have to be in the curly braces. whenever you write a Java class, the very first statement Java would expect to have in the class is package name. So make sure that you have package as a keyword and then the actual package name as the package name for that particular class. You can see the package follows a dot convention and it always ends with a semicolon, like all the Java statements end with semicolon. So that would be the first thing which you will write in your class. Second thing is the access modifier of the class. Like I said, you want this class to be accessible to every other file in this project. Then you can mark this class as public. The next thing is the class keyword. You need to write this particular keyword as is, otherwise your class will not be detected. So you write this as class. Then you write test hello world or whatever name you want to write. But make sure that whatever public class name you provide here, that name should match with the file name. These two things should match, the file name and the class name. If they don't match, you would experience weird behaviors as the class will not be compiled or class might not be able to run, etc. So always make sure that whatever file name you provide, you always have a class with that name in your file. So my class structure is ready, but there's nothing here in this class. In fact, you cannot even execute this class, because for executing the class, for executing any class in Java, any class at all in Java, you would need a main method in Java. Main method is the entry point method of the Java. Whenever you are trying to run any application, be it a very small or very large Java application, you would always need a main method in the class, in the project somewhere. And you need to tell the Java runtime to execute that class, and then the class will have a main method and your program will start executing. So always have a main method, otherwise your program will not execute. And how do you write the main method? So you first write public, then you write static, then you write void, and then you write main, and then you provide a parameter to this method as this. Now let's understand what did I actually write here. First keyword is public, because this method has to be public, because like I said, Java runtime needs to be able to access this method. So the similar concept which applied on the class is applied on this method as well, that the entry point method has to be public, otherwise Java will not be able to find this method. So you need to make this method exactly as public. The next keyword is static. You again need to write this keyword as is, and the reason we write static here is because we want to run this particular class without creating an object of the class. Static is again a keyword which we'll cover in the upcoming lectures, but for now you can understand that whenever you want to access something within the class without creating an object, then you need to create it as static. The next is void. Void is basically the return type of this method. The method name is main, and it has to be main. It cannot be main1 or main2. Otherwise, if you do that, Java will not be able to run your program, because it will expect you to write this particular method exactly as what I have written here. No changes at all should be there. If you make any changes, Java program will not run, because it will not be able to find the entry point method, which is the main method. So public, static, void, main. Remember that you need to have this in your program. So void is the return type, which means that this particular program, it will not return anything back to the runtime, because a method can have this capability to either return something or not return something. For example, a method which can add two numbers will return the result of addition, right? So we return the result. Return is the word here. In this case, this method is not expected to return anything, because there's nobody consuming it, right? Java runtime will not do anything with the return value of this particular method. That's why Java will force you to write void here, and main is the exact method name which you need to use. Java will expect you to supply a string array argument. If we covered arrays in bit detail in the previous lectures, and we will cover arrays in the next lecture in very detail. But you can, as we discussed, that array is basically a sequence of characters or words or integers or anything, right? So in this case, this is basically the mandatory parameter which you need to write as is. This parameter name can be anything, obviously. It can be arg, args, or whatever you want to write it as. But the basic fundamental is that Java will basically supply all the command line arguments using this particular string array. That's why you need to provide this. Then let's write something in the program, because this is a hello world program. So I will just write system.out.println, and I'll type a string here which says hello world and a semicolon. So again, I have been saying that I will explain this, and now I will explain this. Why do we need this and what does this mean? So as I've told earlier, that whenever you want to print something on the console in a Java program, you need to write system.out.println. Now system here, if you just hover over it, Eclipse will show what it is. So system is basically a class which contains several useful class fields and methods. It cannot be instantiated, means you cannot create an object of it, and it provides many facilities like standard input, standard output, and error output. Exactly what we want to focus here, because we want to use system class to print something on the standard output. The standard output in this case is the console. So if you want to input something, or you want to output something, or you want to output an error, then you need to use system class. And all of these, standard input, standard output, and error, are streams. And that's what comes to the next word. What is this out? Out is a stream to print standard output. Similarly, we have system.err, which is for printing the error output streams. Similarly, we have system.in for taking its standard input streams. So system.in, system.out, system.err, these in, out, and err are streams. And then println is the actual method. Let's hover over that. Let's first see out here. So you can see this is a stream object which is used to print anything which is ready to accept output data basically. And then we go to the println method, and it says prints a string and then terminate the line. So like I mentioned earlier as well, this whole syntax is used to print, and actually this is the core method. This is the real method which prints something on the console. So system class uses the output stream to print something on the console using the help of println method. There is also a print method. So there are two methods. One is print and one is println. The difference is that in case of print method, the print method will not provide you or terminate on a next line, but in system.out.println, the ln means line here. It will print something and it will bring the cursor to the next line. If you do not use this, and if you again use another print statement, then both of the statements will be printed on the same line. I will show that as well. But and then we provide any random string here which we want to print. So you right click on this particular program, you go to run as, and you run as Java application, and you want to save this. So you can say always save resources before launching, and you see the output here. So this is how you can run your first Java program. Now let's also see the difference between system.out.println and system.out.print. So I will just copy this here, and I'll say hello world 1, let's say, and this time I will not use system.out.println, but I will use system.out.print. Just put a space here so that it's visible. So if I use print, how does that look like? I go to run, and I go to run as Java application. So now you see both of the outputs are printed on the same line. There is no, this output hasn't gone to the next line. And now if I run the same program with system.out.println methods, now both of these outputs will be divided on two lines. The first output, then a line break, the hello world 1 goes to the next line. In the previous run, the hello world 1 was printing right next to it on the same line. So that is the difference. So this is how you can build your very first program, the hello world program in Java. And this is where I would like to end this particular session as well. In the next session, we will be discussing about arrays in Java. So as I described earlier, that array is basically a container which can store values, or a sequence of values, or sequence of numbers, or sequence of characters into itself. We can think of it as a box which can store all the values in a continuous fashion. As you can see here, this is just a pictorial representation, and this is coming from the official Java docs. And you can see that if we create an array of size 10, then we have these 10 blocks created here. You can see 1 to 10th. So the whole length of boxes, the number of boxes here are 10. But the way arrays are designed is that the index is basically used to access the element in this particular box, the index of the boxes start from 0. So it goes from 0 to 9. So remember, the array length is 10. The array can contain 10 elements, but the index of the array starts with 0 and will always end at length minus 1, which is 10 minus 1 in this case, which comes as 9. So it will always be length minus 1. It will always the index will always start from 0 and go till length minus 1. Length can be anything. In this case, the length is 10, so the index ends at 9. If the length was 20, the last index will be 19. But in total, you have these 10 memory locations. We also call them as continuous memory locations because they are continuously placed. An array basically blocks 10 memory locations and creates a container over it. So this is how an array basically looks like inside the memory. And whenever you want to access the elements of the array, you will say array of 0 or array of 1 or array of 2. You basically need to specify the index to access the element at index. For example, if you want to access the element which is sitting in this box, you need to say array of index 8. And we'll see how we can do that. But this is the basic understanding and idea of the concept of arrays. So let's try to understand this with the help of an example. I will switch back to Eclipse IDE, and I've created a very simple program here to demonstrate the functionality of arrays here. So we already covered in the previous lecture of what is package and what is public and what is class, how do we give the class name, and what is the meaning of this particular method. So I'm not going to cover that again. We'll start directly from here. So here the first thing which I'm doing is I'm declaring an array of integer. This is a variable name, the identifier basically. It can be anything. And this is the data type. It's an integer array, and as we covered this as well, that whenever you put square bracket in front of a data type, it becomes an array data type. So this is an integer array representation. Now we just declared an array, but we still haven't allocated a size to it. So you can do that with this particular syntax. So you can put the variable name of the array and say new int and put the right size here. This size can be anything. And once you do this, now array will actually allocate those memory boxes which we covered here. The moment you do new int 10, these boxes, continuous boxes, will be placed in the memory, and the memory is allocated to this array. We call this memory allocation. This is how you allocate memory to the array. So we allocated memory to this array for storing 10 integers. The next thing is now we can start storing elements in those boxes. So like I said, that the array index always starts with 0. So if you have to store the first element, you actually have to store it at index 0 location. So you give the array name, you provide these square brackets, and you put the index value within the square brackets. That is how you basically point to a particular element inside the array. So we say an array of 0 and we put the value 100. Then we initialize the second element, which will be index 1. Then will be the third element, which will be index 2. Fourth element, index 3. Fifth element, index 4. Sixth element, index 5, and so on. Until we store till the last element. So this is the 10th element, which is accessible as index 9, and the value is 1000 basically. So from 100 to 1000, we stored 10 values in this array, and we stored them by accessing the index. And this is actually the only way you can store values in the array, by pointing to the indexes. So we go from 0 to 9 and we stored all the values, 0 being the first element and array of 9 being the last and the 10th element. Remember the length minus 1 concept. Okay, so now we will try to print all the elements one by one. That's pretty much what we are doing now. So as we covered in the previous lecture, that we use system.out.println to print anything, and we understood the whole meaning of this, so I'm not going to repeat that. Now we want to print the first element. The first element is sitting at index 0, and we can access that element with this syntax by providing the variable name and the actual index value. So I'm just writing a random string here which says element at index 0, and then I'm putting this plus here and putting the variable name. This plus is basically used to concatenate the output of a static string with a random variable, or basically you can print anything with using plus. Plus is used for concatenation. So I'm just trying to print this whole value, but here this is a string value which is a static string, and then I have a value coming from the array. So whenever you have to print some value from a particular data type or variable or collection, then you can use this plus syntax to concatenate a string, static string, with your actual value. So that's what I've done here by saying plus and array 0. And similarly for index 1, I'm printing the first index, then for 2, 3, so far and so on so forth till the index 9. So basically I'm just printing all the values of the array starting from index 0 to index 9. So that's all which is written in this program. Now let's try to run this program. So I will right click, go to run as, and go to Java application and hit on this. And now if I just expand this console, you can see all the system.out.println statements have been executed and they printed this. So this is the static string part, in fact including the colon. This is the static string part, element and index 0, printing exactly as is, and then dynamically the 0th index element of an array is printed here. Similarly, we have printed the index 1 location element, index 2 location element, index 3 location element, and so on so forth till the index 9 location element. So in total these are the 10 elements, but the index always works from 0 to length minus 1. In this case it will be going from 0 to 9. So this is basically all which I wanted to cover in this lecture. The whole idea was to give you more understanding of arrays, and remember this is just an integer array. You can similarly create a character array. You can also create a string array for you as well. So it's completely related to the data type you are using. If you create a char array, then you can only store characters into it. If you create a string array, then you can only store strings into it. And now you can probably relate back to this particular thing which I explained in the previous lecture, that we create this string array for the reason that when you run this particular program, and if you want to provide any command line values, command line arguments to the program, those arguments will automatically be stored in this args, and then you can access this as args of 0, args of 1, etc. in your program. That's the whole concept. So this is basically the deep dive on array which I wanted to cover. And in the next session, we are going to cover about operators in Java. When we talk about operators in Java, there are multiple types of operators like assignment operators, arithmetic operators, unary operators. Then we have conditional operators and logical operators. And we also have bitwise operators. And we will cover all of these operators one by one. We will understand what these operators are and how they work. And we will also look at a demonstration of it. So let's get started. The first operators we are going to discuss is about arithmetic operators and assignment operators, and we will also see if we can cover unary operators. So when we talk about assignment operators, I have again opened the official Java docs here. If we understand assignment operators, we have been using these operators all the while in all of the demos so far. And the basic idea is very simple. Whenever you assign a value to a variable, you use the assignment operator, which is nothing but the equal sign. We have already covered this in multiple demos, so I will not cover this as part of the demo. But what I'm going to cover in detail is about these arithmetic operators. So arithmetic operators are basically used to perform any kind of arithmetic operation on a Java program. It can be an addition operation, it can be a subtraction operation, it can be a multiplication operation, a division operation, or an operation by which you can find the remainder of the division. So we will look at each of these with an example, and as you can see, the symbols are expectedly what you generally use in mathematics. So you see the plus sign here, which is for addition. You see the minus sign, which is for subtraction. You see the star sign, which is for multiplication. You see the slash sign, which is for division. And you see the percentage sign, which is for finding the remainder of a division. So let's see an example of each of these and how we can use them in a Java program. So for the arithmetic operations, I have prepared a demonstration of it in the Eclipse IDE. Again, I'm using the same Java project which I have shown you we created in the previous lectures. So for all the demonstrations, I will just continue in the same project. So Again, the way to create a class remains the same, exactly the same as how I covered in the previous lecture in the Hello World program where we created a class. So here also I created a class. I named the class as arithmetic demo, and I have a public static void main method inside this particular class, and I have basically tried to demonstrate each of the operation. So let's start with the addition operation first. So I create an integer variable here named as result, and then I try to use the addition operator to make this variable store the result of this addition. So it's a simple 1 plus 2. You can also create two different variables for 1 and 2. Let's say x equal to 1 and y equal to 2. And you can also do int result equal to x plus y. It will have the same effect. But just for simplicity, I have put the literal numbers here. So result is storing the expression value of 1 plus 2. And then I'm printing this value here. You can see I'm printing the result variable here with using system.out.println. Then I'm storing this result into a variable, into a new variable, original result, with using the assignment operator. And then I'm trying to subtract something from it. So now I'm saying result equal to result minus 1. It means whatever the current value of result is, subtract minus 1 from that value. So the value was 3 here, and here 3 minus 1 becomes 2. So the new value of result becomes 2. The original result still holds 3 because it is storing the old value. The new value of result has now become 2. So I'm printing the original result, and then what I'm doing, that I'm again assigning the new result, which is 2, to the original result. So now original result and result both are at 2. Then I move ahead and I try to demonstrate the multiplication operation. So I take the same variable result and I say multiply it by 2. So whatever the value of result was, which at this place should be 2, multiply that value by 2. So 2 into 2, the new value of result should become 4 after this multiplication operation. And again, I'm assigning the value of original result to this particular variable. And then I'm showcasing the fourth mathematical arithmetic operation, which is division. So you can see result by 2 here. So basically, whatever the current value of result is, I'm dividing that value by 2. So 4 divided by 2 should become 2. So again, the new value of the result variable should become 2. Then I'm printing the value and again storing the value back into the original result. Then the next operation is again an addition operation where whatever the value of result is at this particular point, which is 2, add 8 to that particular value. So the new result value becomes 10, and then I'm printing that particular value, again assigning the original result to the result. And then to showcase the remainder operation, I'm doing result. We call this particular operator as mod or modulus. So result modulus 7. So the current value here is, in this case, would be 10. So I'm saying 10 mod 7. So 10 mod 7 would become 3, because if we divide 10 by 7, the remainder should be 3. And this modulus operator is used to calculate the remainder of a division operation. So that 3 will be stored in this result variable, and then we print that particular variable. So that is what I'm doing. If I take you back up there, I'll just minimize this window and this window as well. So if I take you back to the starting, I'm doing an addition first here at line 7. Then I'm doing a subtraction at line 12. Then I'm doing a multiplication at line 17 and a division at line 22, and then again an addition at line 27, and then a modulus at line 32, and I'm printing the respective values. So let us run this program and see what results do we get. So I right click, I go to run as, I go to Java application. There is also a shortcut for it. If you want to use the shortcut, you can use that. So I click on this and the output is displayed here. So you can see, let me bring this output back to its original position. Yeah, I just dragged it here to the top, to the bottom. So if we start from the top and see what all results did we get printed. So line 9 says 1 plus 2 equal to the value of result. So 1 plus 2 equal to, at this particular point, the result value was 3 because 1 plus 2 equal to 3. Moving on, the next variable here is minus. So the current value was 3. We said 3 minus 1, which becomes 2. And we store the value of result or 3 into this result variable, and we print that value at line 14. So original result plus original result is 3. Then a string here -1 equal to, so this is just a string, and then the actual current result value, which is 2. So far so good. We move ahead, and then at line 19 we are multiplying the current value of result by 2 and again displaying the original result and the current value. So 2 is the original result here, because here 3 minus 1 had become 2. So original result value was 2. Multiply that by 2 becomes 4. Then moving on to the line 24, 4 by 2 should become 2. So 4 by 2 equals 2, the current value of result. Then again moving on to the next variable at line 29, now the result value should become 10 because 2 plus 8 is 10, and again we are printing the original result and then the current result value. So the original result was 2, then we added 8 to it, and the new result value had become 10, which is coming from this particular variable. Moving on to line 34, we are again printing the original result, which was 10 here, and then we are saying this particular string, which is modulus 7, and the current value of result is coming from this expression, which is 10 modulus 7. And like I said, modulus or mod operation is basically used to calculate the remainder of a division operation, which, so 10 divided by 7, remainder is 3. So that becomes 3, and that's why you see the value 3. So this is a demonstration to show you how we can use the addition, multiplication, subtraction, division, and modulus operators, which are all the arithmetic operators. And I think this is where we should stop this lecture. So in the next session, we will be discussing about the other operator types, which are unary operators, and we will also discuss some other interesting operators which are popularly used in Java. So when we talk about unary operators, technically they are also arithmetic operators, but they provide a increment operator and logical complement operator. So when we talk about the unary plus operator, basically it is used to indicate a positive value. So whatever value you are having, it will just make that number as positive number. You might be wondering that this plus has an addition meaning as well, right? Which we saw in the previous example. Yes, that's correct. But when we use that addition symbol, we use that between two variables. But when we talk about unary operators, they are used with a single variable. That is why the name unary, because they are used with a single variable. They require only one operand. So unary plus basically makes any number positive. Unary minus negates an expression and makes that number negative. Increment operator increments the value by +1. Decrement operator decreases the value by -1. And logical complement operator inverts the value of the expression from true to false or false to true. Let's understand this with the help of an example. So I have created a class here called unary demo, and I have a static void main method here, and I have created a variable called result, and the first example is about using unary plus. So I'm creating a variable called as result, assigning the value as 1 and just putting 1 plus in front of it, which makes this as positive value. Though we can argue that this also has the same effect as this, and yes, that is true. But in case if this value was written as something like -1 instead of plus, then we could basically make that number positive by just putting plus in front of it. So that's basically the power of unary operators, and that's how you generally use unary operators. So I'll just put it back to +1. The next example is about decrement operators. So the current value of result was 1 because we did this. Now we are saying result minus minus, which means whatever the value of result is, just decrement it by 1. So the current value was 1. So now the new value of result after this evaluation becomes 0. So at line 14, we print the current value of result, which is 0. Moving on at line 16, we are using the increment plus plus operator here, which means whatever the current value of result is, just increment it by 1. So the current value of result was 0 till this line. So it becomes 1 because this means increment by 1. So line 18 will basically print that value 1. And then at line 20, I'm using the unary minus operator, which means whatever the value of result is, just negate it. Just put a negative in front of it. Just make that number negative. So if I just say minus result, the current value of result was 1, so it became -1. And then to showcase the negation operation, I created a Boolean variable, named it as success, assigned the value of this variable as false, and printed the value of success variable as is first, and then printed the value of success with a negation in front of it, with an exclamation mark, which will basically flip the value or invert the value of a Boolean variable. So if this was false, line 28 should print true. If this was true, line 28 should print false. In this case, this is false, so the line 28 should print true. So let's right click on this and run this program and see if we get the expected output. And yes, we see the output here. So let's try to interpret the output now. The line 10 should print 1. Yes. Then line 14 should print 0. We see 0 here. Line 18 should print 1 because we use the increment plus plus. So 0 plus 1 became 1. Then we use the unary minus operator. So the value should become -1. Yes, we see -1 here. And then for Boolean variable, we should see first the false because the value is printed as is. And then we are printing a negated value. So we should flip the value from false to true. And yes, it is printing the value as true. So this was about unary operators. Now, when we talk about these increment and decrement operators, what if I put this particular value in front of result? What effect is that going to happen? Let's analyze that part as well. So for that, I have prepared a separate demo. Again, I've created a class called pre-post demo, and it has a public static void main method. I'm declaring an integer variable I with the value as 3. So the I becomes 3 here. And then I'm saying I++. As we have already seen in the unary demo example, this should increment the value of 3 to 4. So it will print 4, expected, right? Then at line number 9, I'm putting this plus plus in front of I. Now what will happen? Now it is going to increment the value of I and then basically assigning the value of I. So the whole difference between I++ and ++I is that in this case, the value of I is assigned first and increment later. In this case, the value of I is incremented first and assigned later. So here the value from 4 becomes 5. So at line 11, if you see, if we print I, it will print 5 because we are saying that first increment the value and then update the value of I. So increment happens on I equal to 4 and I becomes 5. At line number 13, it becomes more interesting because here inside the system.out.println statement itself, I'm saying plus I. Now what will happen? Like I explained, first the value will be incremented and then the value will be assigned. So before printing, the value is getting incremented. So the value from 5 becomes 6 here at line 13. But if I try to do this, now I'm saying first assign the value of I and then increment it. So I at this line is still 6 because I has already been assigned 6. And as the post increment says, if you put this plus plus after the variable, it means that you are first assigning the value and then incrementing the value. So anything which happens after line 15, the value of I will become 7. But at line 15, the value of I is still 6 because we are using a post increment operator. So the value is still assigned to I as is and then incremented. And when we do system.out.println, the assigned value is printed, not the incremented value. So like I said, after line 15, the value of I will become incremented by 1 and it will become 7. So hope you understood this example and the difference between the pre-increment and post-increment. Remember the thumb rule that if we put plus plus before a variable, like at line number 9, the value will be incremented first and then assigned. So at line 13, the updated value will be printed because the first we are doing the increment and then we are printing the value or assigning the value. Similarly, at line 15, we are first printing the value and then incrementing the value. So when the value is printed at line 15, the old value of I will be printed, but after line 15, the new value of I will be accessible to the program. So let's right click on this and run this program. And now if we see the values, we assigned I to 3. We did a post increment here. So I becomes 4. We print the value of I. So here the value of I is 4. We see 4 here. Then at line 9, we are saying plus I. So 4 plus 1 becomes 5. Though this is a pre-increment, but since we are not printing this plus I as is, it does not have any change. So the value of 4 becomes 5. At line 11, we print 5. Then at line 13, we are saying plus I, which means increment the value of I first and then assign it. So the value of 5 becomes 6 and then I gets updated and printed. Similarly at line 15, first the value of I is assigned and printed and then incremented. So at line 15, the value is still 6. You see this 6 here, and then the value is incremented. So after line 15, the value becomes 7. So that's how we are basically using the unary operators. And this is where I would like to end this particular session. In the next session, we will be discussing about other type of operators, which are comparison operators and logical operators, etc. When we talk about relational operators, they are sometimes also called comparison operators. And the basic idea behind using these operators is to compare things or compare the values of variables or compare the objects in Java. So in Java, if you need to compare anything, for example, if you want to compare if something is less than the other thing, or something is greater than the other thing, or something is equal to the other thing, then you need to use the comparison operators which are provided by Java. Here you can see I have opened the official Java docs, and you can see a bunch of comparison or relational operators. Both of the terms are used interchangeably. Some people call them comparison operators and some people call them relational operators. So you can see if I want to compare if an object or a value is equal to another value, then I use the double equal sign. If I want to compare for non-equality, I will use exclamation with an equal to, which means not equal to. If I want to do a greater than comparison, then I will use the mathematics greater than symbol. If I want to do the greater than equal to or less than equal to, they again follow the same kind of terminology as we see in mathematics. So this is all we have in terms of the relational operators. So let's understand the usage of these operators with the help of some examples. So as you can see, I have created a class here, which is called comparison operator. There is a public static void main method inside this class. And this method has two variables of integer type called value1 and value2. Value1 has the value 1 and value2 has the value 2. And then I am trying to compare the value1 and value2 variables using the different relational operators we just covered. For doing that, I need to use a conditional operator as well. We will be covering conditional operators in much detail in the upcoming lectures. But for now, you can understand that when we talk about conditional operators, we talk about if and else statement. So if is again a keyword in Java, which can be used to compare things. And the syntax is very straightforward. You write the if keyword and then you write the actual comparison syntax or the actual comparison expression. So in the first example, we can see that I'm writing a condition which says evaluate if value 1 is equal to value 2. I should put a curly braces around here. You can see there are no curly braces here, but that is for a case when you have only one statement under it. But again, I will cover this in detail and I don't want to confuse the audience here. So I will just put curly braces around all of these if statements so that it becomes easy to interpret what is actually going on in these code blocks. As we know that these curly braces are used to define a code block. So the first if block says compare if the value 1 is equal to the value 2. If yes, then this condition will become true and the control of the program will go at line number 10. If this condition is not true, then the control will not go inside 10 because this condition is false. So it will never go to line 10 and it will move to line 11 or 12 instead. Similarly, the next condition is we are comparing the value 1 is not equal to value 2. So this condition will only be true if these two values are not equal or unequal. And if that is the case, then line 14 will execute it. Otherwise, line 14 will not be executed. Similarly, in this condition, I'm saying compare if value 1 is greater than value 2 or not. So if the actual value holded by value 1 variable is greater than the value 2 variable, then this condition will become true and the line 18 will be executed. Otherwise, it will be skipped. Then similarly at line 20, I'm doing the reverse. I'm comparing if value 1 is less than value 2. If that is the case, then line 22 will be executed. Otherwise, it will be skipped. And at last, I'm also showcasing an example of less than equal to operator that you put less than and equal to together. And again, you compare the two variables. Similarly, you can also use greater than equal to variable comparison operator as well in this example. So we have an example of equality, not equal to, greater than, less than, and less than equal to. Let's run this example to understand. So for running the example, I will just right click here, go to run as, and click on Java application. And we can see the output here. So as the value 1 holds the value 1 and value 2 variable holds the value 2, obviously 1 is not equal to 2. So the first condition is not going to be evaluated to true. So line 10 will never be executed because 1 is not equal to 2. Similarly, if I talk about the next condition, which was if value 1 is not equal to value 2, then execute statement 14. And yes, 1 is not equal to 2. That's why we see this particular system.out.println here. We see this printed. Moving on, is value 1 greater than value 2? So is 1 greater than 2? No, it's not. So line 18 will never be executed. Then the next one is value 1 less than value 2? So yes, 1 is less than 2. So line 22 will be executed. And we see the line 22 output here, system.out.println output. Moving on, is 1 less than equal to 2? Yes, 1 is less than equal to 2. So this particular condition is also true and line 26 will be executed. And that's why we see this here. And that's all. So we can see that we are able to use these comparison or relational operators to evaluate different conditions. And we write those conditions using the if block. And again, if you do not understand the if block fully, don't worry. We will be covering the if blocks in detail. But the focus here is in using the operators, the not equal to operators, the greater than equal to operators, less than equal to operators, etc. So I hope these operators give you a better understanding of how to use them. Now moving on to the next section of this comparison operators, sometimes we also use some logical terms to do the comparison. For example, if I just move down here and I show you these conditions here, we call them conditional operators. Conditional operators are used to evaluate the conditions like and or, and we use them in two ways. Either we can use it as ampersand or double ampersand, or we can use them as pipe or double pipes. So the idea is basically to evaluate if one condition is true and other condition is also true, or one condition is true or other condition is true. So whenever you want to combine two conditions together, that's where you're going to use these logical operators or conditional operators. You can also use the simple English keywords like and or you can use the logical representation of these keywords. For example, ampersand, ampersand, or double ampersand is equivalent to and. Similarly, double pipe is equivalent to or. So we can use these as well interchangeably. You can use either of these operator representations to run a conditional check in composition, meaning you can compare two conditions saying, okay, if one is true and second is true, or one is true or second is true. So the whole focus is here in and or comparisons. So let's switch back to the IDE and let's look at an example of this to understand this in detail. So I will again take the similar kind of example. Again, I have created two variables here, value 1 and value 2. Value 1 has value as 1 and second variable value 2 has value as 2. And then I'm writing two conditions this time in the same if block. You can see I am writing first condition saying is value 1 equal to 1 and is value 2 also equal to 2. So this whole if condition is only going to be true only if both of the conditions are true. That's the property of and will force that both the conditions on the left hand side of it and the right hand side of it hold true, and then only the whole expression is going to hold true. Even if one of the conditions evaluate to false, the whole if expression will evaluate to false. Similarly, for or conditions, we again write a left hand condition and a right hand condition, and in between we write this double pipe. We can also write or in English. That will also have the same effect. And this will evaluate in a way that this whole expression will evaluate to true if even a single condition, either on left side or right side of it, becomes true. So OR will just need one expression to be true to make the whole if condition true, whereas AND will force both of the conditions to be true to make the whole expression as true. So AND will require two trues to actually become true, but OR condition will require only one true to become true. So if we try to do understand this logic, here I'm saying that if value 1 is equal to 1, which is correct, and value 2 is equal to 2, then make this condition as true. So yes, in this case, this condition will evaluate to true because value 1 has value 1 and value 2 has value as 2. So it will print the line 10. Whereas in the next condition, I'm saying evaluate if value 1 is equal to 1 or value 2 is equal to 1. So either of the expression if becomes true, either the left side, this expression, or the right side, this expression. Either of the expression becomes true, this whole condition will become true and line 14 will be executed. Line 14 will not be executed only in a case when both of the conditions here become false. For example, if I write it like this, then we know that value 1 is not equal to 4 because it's 1, and value 2 is not equal to 5 because it's 2. In that case, both of the expression will become false, and then line 14 will not be executed. If I write it like this, then the left hand expression is evaluated to true because value 1 is 1, but the right hand expression is false. But it's fine. The line 14 will still be executed because either of these side is true, so the whole expression becomes true. Similarly here, AND will require both of the expressions to be true, and if either of them becomes false, then the whole expression becomes false. So in the current state, line 10 will be executed, but if I change this to this, then the left hand side of this ampersand will evaluate to false, and the whole expression will evaluate to false in that case, and line 10 will never be executed. Let's try to run all of these scenarios to make a better understanding of this. So in this case, both of the conditions should work fine. So I will just right click and run as Java application. And yes, we see this line 10 being printed, and we also see this line 13 being printed. So both of the lines are printed correctly. Both of the conditions are evaluating to true. Now let's try to play around with it. Let me change this value to 4. So now value 1, this left hand side expression is false, which should make the whole expression as false, and it should not print the line 10, which is this statement. So let's run this program and see if that works. Yes, we see that this particular line is not printed now because this whole expression became false because the left hand side of this expression became false. Similarly, in the OR case, either of them have to be true. You can see currently value 2 equal to 5 condition will actually result in a false condition because this is not a true. Value 2 is actually 2, not 5. And still we see this particular expression because either of them have to be true. If I make both of them as not true, now both of the conditions on the left hand side of pipe and right hand side of pipe are false conditions. What will happen now? Nothing will be printed. The reason for that is that value 1 is also that this condition is also false and value 2 condition is also false. So the whole expression became false and this was already false. So this is all I wanted to cover in this lecture. We covered about the comparison operators and how to use them. And in the next lecture, we are going to talk about the bitwise operators. Bitwise operators are very less commonly used in the Java programming world. Generally, we don't use them, and generally, we don't need to use them. You would generally use them when you are doing really complex bitwise calculation where you need to manipulate the bits. Now, what are actually bits? So if you remember when we talked about the integer type variables, we talked about how much memory each of the variable type or data type was going to consume. We said that this will take 1 byte and this will take 2 bytes, etc. 1 byte is basically made up of 8 bits, and bits are nothing but positions where either a 0 is stored or 1 is stored. Actually, the whole machine will convert your whole program ultimately in zeros and ones, which are nothing but bits. So if you want to do the manipulation at that level, so now you can understand you are actually working right at the machine level understanding. So if you want to manipulate the bits which are going to be understood by the machine at that level, then you can use bitwise operators. But like I said, generally we don't need to use them. Now, when we talk about bitwise operators, there are multiple ways in which we can use them. We can use them with the standard and or operations. If you remember, we covered this and or operations in the previous lecture. You see a difference here that in case of and, we are using a single ampersand and not double ampersand. This is one of the concepts which we did not cover in the previous lecture, and I would just like to brief you about this concept that if you use double ampersand, that is also called a short circuit operator. And if you use a single ampersand, that is called a standard operator. To build an understanding about this, I will just quickly recap of what we covered in the last lecture and we'll try to explain these concepts as well. So let's go to the logical operator demo. And here, if you remember, there were two ampersands and two pipes. This is also a valid expression. A single ampersand is also a valid expression. The only change is, in this case, even if the left hand condition evaluates to false, still the right hand condition will be evaluated. Although we know that in case of and, either of the expression needs to be false and the whole expression becomes false. So Java provides an advantage with that if you use double ampersand, and if the left hand operation becomes false, then it will not cover the right hand operation. It will not even evaluate the right hand operation because it doesn't matter. If the left hand operation has already returned to false or evaluated to false, then no matter whether right side is true or false, the whole expression is still going to be false, right? That's the property of and. One of the side has to be false and the whole expression becomes false. So why evaluate two sides? Why waste the memory in evaluating the right side when the left side has already turned as false? Java takes advantage of that, and that's why if you use double ampersand, you save a bit of processing power of your computer by just evaluating the left hand condition. And if the left hand condition is false, it will skip evaluating the right hand condition and just make the whole expression false. But if you use this, a single ampersand, then both sides of the expression will be evaluated irrespective of their output. So in this case, even if the left hand expression is false, it is still going to evaluate the right side expression. And similarly, it works for the OR case as well. In this case, in OR case, as we know, if one of the condition is true, the whole condition becomes true. The whole expression becomes true. So if the left hand side becomes true, and if you use a single pipe, then it will still evaluate the right hand side. But if you use double pipe like this, then if the left hand side becomes true, then it knows that it does not matter if the right hand side becomes true or false, because ultimately the whole expression is going to be true if either of the side is true. So if the left hand side is already true, it will not evaluate the right hand side and it will say the whole expression is true. That's why you see the single ampersand being used for bitwise, just to explain why it is used and how it is used. For OR operations in bitwise, you use this cap or whatever you want to call it as. And for the inclusive bitwise or operation, you're going to use a single pipe. You also use some shift operations where you shift the value of bit of a particular variable to either left or right. Again, these are again very complex calculations. If you want to use that, please read about this and use that. But in today's demo, what we are going to cover is the and or examples of bitwise operations. So here I have again created a class called bitwise operator. I have a public static void main method. I have two variables here, which are int a equal to 5 and int b equal to 7. Now these 5 and 7 are actually stored as bits, as zeros and ones in the computer's memory. So how they are actually stored? They are stored in a standard bit representation, which you may have studied in your mathematics. If to give you a recap, this 5 will basically be written in the memory as this 0, 1, 0, 1. And it starts from here. 2 raised to power 0 into 1 becomes 1. 2 raised to power 1 into 0 becomes 0. 2 raised to power 2 into 1 becomes 4. And 2 raised to power 3 into 0 becomes 0. So 0 plus 4 plus 0 plus 1 becomes 5. And that's how 5 is displayed to you. Similarly for 7, 2 raised to power 0 into 1 is 1 plus 2 raised to power 1 into 1 is 2 So 1 plus 2, 3, plus 2 raised to power 2 into 1, which is 4. So 1 plus 2 plus 4, 7. And 2 raised to power 3 into 0 is 0. So 0 plus 4 plus 2 plus 1, which is 7. And that's how this 7 is built and stored. And now if you try to do this, if you try to write this condition, you can also write the condition into a system.out.println block, and it will basically evaluate this condition. So now if you say A and B, in this case, this is going to do a bitwise operation because this is bitwise operand. It is going to do a bitwise operation, and what would be the result if you do an AND on this? So again, use the same logic as if in case of AND, if 1 is false, then the whole expression is false. So 0 and 0 becomes 0, 1 and 1 becomes 1, 0 and 1 becomes 0 because 0 means false and 1 means true. So if either of them is false, the whole evaluation becomes false. So that's why 0 and 1 becomes 0, and 1 and 1 is always 1. The value of this is again 5, as we already have evaluated. Similarly, if we do a bitwise OR, and if we do this, again, we are doing an OR operation. So 0 or 0, or basically false or false, becomes false. True or true becomes true. False or true should be true because one of them needs to be true. So this is false, but this is true. So the whole value becomes true. And finally, true or true is also true. So this is the final bitwise OR result. And if we convert this into an integer representation, that becomes 7 because 2 raised to power 0 into 1 is 1. 2 raised to power 1 into 1 is 2. So 2 plus 1, 3, plus 2 raised to power 2 into 1, which is 4. So 4 plus 2 plus 1, which is 7. And plus 2 raised to power 3 into 0, which is 0. So 0 plus 4 plus 2 plus 1 becomes 7. And that's how you get actually 7. So let's see if we get 5 or 7 in this bitwise operation. Yes, we can see the values as 5 and 7. So this is a bitwise operation happening. Similarly, you can also use the shift operations where in case if you're using this particular kind of representation or this particular kind of representation, they are called left shift and right shift operations. So if you use this in front of a variable, then for example, this 1 will be shifted here, and this 0 will be shifted here, and this 1 will be shifted here. So that's how the whole value is going to shift. Whole bits are going to shift one by one towards left. Similarly, if you're using the right shift, then all the bits are going to be shifted towards right by 1 bit. That's the whole concept of left shift and right shift bitwise operations. And if you want to know more about this, please read some official examples from the Java doc and some other examples available on the internet to build an understanding on this. So this is all I wanted to cover in this lecture. So in the next session, we are going to talk about the control flow statements like if, else, etc. So what are control flow statements and why do we need them? Control flow statements are the ones which can help you control and define the flow of execution in your program. Now, why do we need them? Is because if we want to evaluate some conditions or we want to create some branches of execution saying that if this condition becomes true, do this, and if this condition becomes false, do that. So you can see there are two different branches of execution of a program in this kind of approach. And that's where control flow statements can help us. There are a lot of different types of control flow statements like if, then, else, and switch, and for, and while, and do while. And we are going to cover all of them in detail in this series. So let's get started with the first one, which is the if statement. We covered briefly about this when we talked about operators, and I promised you guys that I will be covering this in detail. And this is the session where we will go deeper into this concept. As we have already understood that if condition is basically used to evaluate a condition if it is true or false. The result of an if statement will always have only two values. It can either have a true value or it can have a false value. There is no other possibility or there is no other value of an if statement or of an if expression. Now, like I explained, if you want to do a simple programming execution where you say if a particular condition becomes true, do this, and if this becomes false, then do that. It means you need to write this else condition as well, that if this doesn't hold true, what do I do and how do I write that? So let's understand that with the help of an example. For this particular example, I've created a class and there is a public static void main method, which is the entry point of this program's execution. I have a variable which is called test score. This is an integer variable with the value 76. And I have a char variable, which is grade. Basically what I'm doing, that based on the test score marks, I'm trying to define the grades which a student will get. So for that, I have built a condition here. So you can see it starts with if, which is a keyword. Then you put these standard braces or brackets and you write your condition inside it. In this case, I'm writing the condition saying that if test score is greater than equal to 90, then the student should get an grade A. So here I've defined this grade variable, and here I'm just assigning the value to the grade variable at line 11. If the test score is greater than 90, the grade should be A. But what if the score is not 90? What if this condition becomes false and you want to do something? In that case, you can write this else block here. We call this else block. So you write else as the keyword, you start the curly braces, and then you define the grade. If the score is not greater than 90, what should be the grade of the student? So in this case, we are saying the grade is F. So if we try to run this example in our mind, we see that the value is of the test score is 76. So 76 is not greater than equal to 90. So this particular condition will not be true. So line 11 will not be executed, but instead else block will be executed, because if the condition goes false, then else block should be executed as per Java. So this block will be executed and grade will get a value of F. And then we are printing this grade value by just writing a system.out.println, a string plus the value. So let's run this particular program and see what happens. We get a grade equal to F here in this sysout or system.out.println. Because this condition was false, so the flow of the control of the program went to line 12 and then to line 30, because this was the else block. So this is one understanding where we can write an if and else logic. In some cases, you might not need an else block. So else block is not mandatory. It's an optional block. If you want to remove this, and if you just want to do a sysout here, that is also fine. Sysout means system.out.println. For shorthand, we sometimes call it as sysout. So you can do something here as well if you don't need the else block. If you need the else block, feel free to write it, but this is an optional block. But in some cases, your conditions will be more complicated than just a single condition. If we try to understand it from a real world example, in real world, you will not have only two grades as A and F. You will have more grades, right? A, B, C, D, so on and so forth. So what are you going to do in that case? For that kind of case, Java provides us with a keyword which is called else if. Else if is just a continuation of if, saying that, okay, if this condition doesn't hold true, evaluate the next one with an else if. So I've commented out this code. Let me put this code back into its place, and then we will walk through this code to understand it. Okay, so I have put the code back to where it should be, and this is how it looks like. So let's just walk through this. The line 10 and 11 doesn't change. It's still the same. But then I have added some additional conditions saying that, okay, if the score is greater than equal to 90, the grade should be A. But if the score is not greater than 90, but greater than equal to 80, then the grade should be B. Similarly, if the score is not even greater than 80, but greater than equal to 70, then the grade should be C. Similarly, if the score is not even greater than equal to 70, but greater than equal to 60, which means basically between 60 to 70, then the grade should be D. And if the score is even below 60, then the grade should be F. So you can see I have basically defined the whole logic for defining the grades here. And it always works in a top-down approach, one by one. The way in the sequence in which you will define the else if block will be the sequence in which they will be executed. So after the condition at line 10, and if this condition fails, line 12 will be naturally executed. If this condition also fails, line 14 will be executed, and so on and so forth. It will never be the case that if this condition fails, then suddenly line 16 is executed, and then again line 12 is executed. It will always work in a line by line fashion. So make sure whenever you are using the else if statements, write it in a sequence in which you want the natural program to be executed. So this is all we have here. And now let's try to run this example. Let me just bring the system.out.println line up, save this file, right click, run as Java application. So we see the value is grade equal to C, which means this particular code block was actually executed. Only this condition held true. Now let's try to understand how this happened. The value was 76. So 76 greater than 90? No, this condition becomes false. So line 11 is never executed. It naturally goes to line 12 because that's where we have defined the next else if block. Is 76 greater than equal to 80? No, it's not. So line 12 condition also becomes false. Line 13 never gets executed, and the control shifts to line 14. And there we have the condition saying that is 76 greater than equal to 70? Yes, this condition is true. So the line 15 gets executed. And once this condition gets true, none of the further conditions will be executed because you only need one true statement, one true execution in the whole if else if block. If that one code block gets true, that code block is executed, and then the execution jumps out of the if else if blocks, and it will directly go to line 22 and it will execute that. Had it been the case that this particular block was also evaluated to false, it would go to line 16, and if this was also false, it would go to the block which is else block. Let's see that. Let's make this value as 56. So now 56 is not greater than 70. So line 15 will never be executed because this condition will evaluate to false. 56 is greater than 60. No. So this will also be false. And ultimately the grade should fall to else block where we are assigning the grade as F. Let's see. Yes, we get the grade F because ultimately this block was executed because all of the above conditions evaluated to false. So this is all I wanted to cover in this if else if demo. There is another addition of another way of writing if statements, which we call as nested if, where we have an if block inside an if block inside an if block, and so on and so forth. How do we write that? And how does the control flows in that kind of an execution? We will cover that in the next session. Now, in the previous lecture, we saw how we can use an if-else block and also an if-else-if-else block. But there is another case where we can use these if statements, and that is when you have nested if blocks. When would you use it? Let's take an example. Let's say you have multiple conditions to check on a particular program, and where the output of the first condition is the input of the second condition, and the output of the second condition is the input to the third condition, and so on and so forth. If you have that kind of situation, you can write it in a nested if statement kind of block. So let's understand this with the help of an example. As you can see, I have opened an example here, which is about nested if statements. I've created a class which is named as nested if demo, and I have created a public static void main method inside this particular class. And now I have declared an integer variable with the value 50. Then I'm checking the first condition saying if I equal to 50. If that condition is true, then I will check the next condition, which is if I is less than 75. And then I am adding one more hypothetical condition saying if this is true, then also check if I is less than 55. So you can see if I equal to 50 holds true, then only this condition will be executed. Similarly, if I is less than 75, then only this condition will be executed. So they are dependent upon each other. This condition block is dependent upon the previous block to be true, and this if condition block is dependent upon this if block to be true. If either of these if blocks don't go true, the next subsequent nested if block will not be executed. So in this case, I'm checking it for first equality condition, saying if the value is equal to 50, then execute this statement at line number 10. Then check if I is less than 75. If that is also true, execute the statement at line number 12. And then if I is also less than 55, then also execute line number 14. I can also add an else block as well anywhere in this nested hierarchy if I want to. If I add an else block here, that else block will be corresponding to this block. If I add an else block here, then that else block will be corresponding to this if block. And if I add an else block here, then that else block will be corresponding to this particular if block. So you can also use those else if and else blocks as well with nested if blocks and make it as complicated as you want it to be. So that's about this program. And let's see if we run this program, what output do we get? And let's interpret that output. So I'll just right click, run as Java program, and I see some output in the console. First, I get I is 50. So line number 10 gets printed because I is 50. Then I also see the next line output as I is smaller than 75. It means this condition was also true because 50 is less than 75. So line 12 also got executed. And then I'm checking if I is less than 55. So yes, 50 is less than 55. So line 14 also gets executed and we get this statement on the console. So this was a simple way to see how we can implement the nested if conditions. Now we are also going to talk about another concept which is used in writing the if conditional blocks, which is called ternary operators. So ternary operators are used as a shorthand of writing if else block. As you can see that these if blocks are quite verbose. We have to write a lot of code to actually write some conditions. In this case, I'm executing 3 conditions, but the code is almost 7 lines or 8 lines. So we will see how we can simplify this if we use a ternary operator. And for that, I have created another class, which is called ternary operator demo. And this particular class again has a public static void main, which is the entry point of this particular program. And then I have declared a couple of variables. First is int a equal to 1, and second one is int b equal to 2. I have also declared a result variable, and we will see how we can use this result variable. And at line 10, I have written my if else expression. So you can see this if else expression doesn't look like the one which we have seen before. So let's understand how do we write it. If you're trying to write an if else expression with ternary expressions or ternary statements, then the first thing which you need to understand is the structure of it. So here, at first, you will specify the actual condition which you want to test in your if block. So this is my condition. Then after that condition, you're going to put a question mark. And after the question mark, you're going to put the actual result which you want to be executed if this condition becomes true. So if the if condition becomes true, what do you want to do? Whatever is that, you will write it here. And then if the condition becomes false, then the logic should go into the else block and the else logic should come after this colon. So all you need to remember is this question mark and this colon. Before the question mark, you're going to write the condition. After the question mark, you're going to write the statement which is going to be executed if this if condition becomes true. And after the colon, you are going to write the else block condition which is going to be executed if this condition becomes false. Another thing to notice is that ternary operators can be used only in cases when you have only one statement to execute in if block and one statement to execute in else block. It cannot be more than one statement. So instead of this, you can also write system.out.println here, which will also be fine. If I just write this system.out.print, not printf, but I want to write println, so I'll just write println. You can also do this. This is also fine. You don't need to store the result, obviously, but you can also write this condition in a way. But this only has to be a single statement. It cannot be more than one statement because this expression can only hold one statement at a time. So use it in situations where you have to check a condition and do something in the if block, which is only one statement, and again one statement in the else block. The same expression can also be written in a verbose if-else way in which we have been seeing it before. And I will also show that to you. And here, where this A and B is going, this is getting stored in this variable called result. So if this if condition holds true, then the result is A, and this is going to be stored here. And if it is going into the else block, then B is going to be stored in the result block. Let's run this program. So we can see we get the value 1 because we have set the condition as A less than B. So yes, 1 is less than 2. So this particular statement gets executed and this value gets stored here in the result variable. So that's how you can use the ternary operators to write shorthand if-else statements. The same expression can also be written in a verbose way. For example, you can write it in this way, saying if A is less than B, then result equal to A, else result equal to B. This code has exactly the same effect as this one line of code. So you can see this is pretty simple to write, pretty short to write. The code which I'm writing here in 4 lines can be written here in 1 line, and that's the power of ternary operators. So this is all I wanted to cover in today's session. So we talked about nested if statements and the ternary operators here, how to use them. In the next session, we are going to discuss about switch case statements. So let us first understand, why do we need switch statements? Generally, whenever you want to check a condition, you can use an if-else block. But what if you have multiple conditions to check? What if you have so many possible execution paths that it becomes too verbose to write it into an if-else kind of block? What if you have to check on constant values of certain expressions? How do you do that? It becomes even more challenging and the code becomes even more verbose. So in such cases, switch statement can be used, in which you can write switch statement to have as many possible execution paths as you want, and it will work with constant values as well. So let's understand this with the help of an example as how and why will we use the switch statements. So for that, I have created this class which is called switch demo, and it also has a public static void main method, which is the entry point. And in this program, what I'm doing is I'm trying to accept a number as the month number in the program. And then with that particular number, I'm trying to print the corresponding month's name. So that's the logic. Pick a month number and you should get the month's actual name. So now in this case, you can imagine there will be at least 12 if-else if blocks, which is a long line of if-else statements. At the same time, if we try to do this for other conditions where the value is constant, please understand that the value of month is going to be constant. It's going to be the same number. So it's not similar to you evaluating a condition. It's similar to you evaluating a condition to a particular constant value. Imagine if you have to do some sort of a classification of employees in higher salaries and lower salaries, and there are hundreds of salary bands in the company. So are you going to write 100 if-else logics? That is going to take a long time. And then what if new bands get introduced? Then it gets even more complex. So we will use switch case statements in cases where there are lots of if-else conditions and the expression evaluates to a constant value. Remember, in the if-else cases, the expression evaluates to a Boolean value. So here I'm supplying the month value as 6. Then I'm also creating a string month string variable just to print or store the name of the month. And then the way you write the switch statement is to write the switch keyword, and then in the brackets you supply the month integer value, and then you start writing your conditions. So you can see you write the case as keyword, and then you write the number or the possible values this particular variable or this particular expression can hold. So all the possible values this particular expression can hold will be written individually as cases. So case equal to 1. Here 1 means the value of month is 1. In that case, the month string which we created here shall store January. And then we see a statement called break. So break is again a keyword in Java, and this keyword has a special meaning. It has a special usage. You will use the keyword break to abruptly break the control of execution from the current code block, and the code block is identified with curly braces. So here you can see the curly brace starts from here and it ends down to line number 51 at here. So the moment your Java program is going to encounter this particular statement, it is going to jump out of the current code block execution and continue thereafter. That's the basic logic and usage of break statement. So use it whenever you want to skip the rest of the code after the break statement. If you don't want to execute the rest of the code, you will write break, and the moment the Java program sees this particular statement, it will jump out of the current code block specified by the curly braces and will resume execution after the code block. So in this case, it will resume the execution after the line 51. That's the usage and meaning of this expression called break. So in this case, we are saying that if the month value is 1, which we denoted as here, case 1, then store the value of the month string as January and break out of this particular code block because we don't need to execute any further. We have found a match. Then another case would be if the month value is 2. So you write case, which is a keyword, and then the exact expression value, the constant value, which is 2. And if that's the case, then month string becomes February. And again, you break because in this particular case, there will only be one condition true at a time. There will never be a case that month with the value 2 will have two meanings, will have two month names. A month with the value 2 will always have a meaning called February. It will never have two meanings or two month names attached to the same integer value. And that's why you do not want to execute any further. And that's why you write this break statement. If you do not write this break statement, it is going to evaluate all of the cases one by one. Even if the cases are not going to be true, but it is going to waste a lot of processing time evaluating all the case conditions which you have written here, which does not make sense because we know that only one condition at a time can be true here because we are evaluating and checking for a constant value, which is an integer value. So that's the reason we put a break in each case. If intentionally, if you want to check multiple cases, do not put a break statement, but the program can become really confusing in that case. So take your wise call. So here we put a break in each case. Similarly, case 3, the month string becomes March. Case 4, the month string becomes April. Case 5 becomes May. Case 6 becomes June. Case 7, we have month string as July. Case 8, month string is August. Case 9, we store the month string as September. Case 10 as October. Case 11 as November. And case 12 as December. After that, you will also see an interesting block called default. This is the another capability of switch statement, that what if none of the above conditions hold true? What if we specify a value which is not between 1 and 12 and it will not match any of the cases which we saw just above? And if you want to execute some code in that case, if none of the conditions matches, you may want to execute some default execution. Also, in such cases, you are going to use default. Default is the code block which will be executed if none of the case matches. So here you can see that if none of the cases match, then we are going to store the value of month string variable as invalid month, and then we'll eventually break out. And once we break out of this program, we just want to print the month string. That's all we are doing in this program, that we take an integer value as the month number, and then we print the corresponding month name here by looking at the case blocks. And we also define a default case block if none of the conditions hold true. So let's run this program. We have specified the value as 6, which should result in the month name as June. And yes, we can see we get June. Let's change the value and let's put the value as 10 and see what do we get. So right click, run as Java application, and we got October. Yes, exactly correct. Let's put an invalid value as 13. And let's see what happens now. Now we get invalid month. So our default code block just got executed because we entered a value which is not matching any of the case conditions which we have specified. So this is how you are going to use the switch and case statements while writing your conditions whenever your condition evaluates to multiple constant values. Remember, the key here is to understand if your expression is evaluating to multiple constant values which do not change. And in those cases, using a switch case block is a better idea than writing if-else statements. So that is all what we are going to cover in today's session. And in the next session, we are going to understand something about two-dimensional arrays and multi-dimensional arrays as well. We have been talking about arrays throughout this course of Java in the previous sessions as well. And we have covered some basic understanding of how to create arrays, how to declare them, how to fill values in the array, and how do we print the array with positions as well as the array as whole. But whatever examples which we took previously were one-dimensional arrays, because arrays can have more than one dimensions as well. You can create a one-dimensional array, you can create a two-dimensional array, You can create even a three-dimensional array, and you can go up to as many dimensions as you can handle in your Java program. So it depends upon the kind of complexity you want to have in your program and the kind of values, the kind of structure you are going to store in your arrays. And based on that need, you can choose whether you want to use a 1D array or one-dimensional array or a 2D array or a 3D array and so on. In these sessions, we are going to talk about 1D arrays, 2D arrays, and 3D arrays. And after that, we'll leave up to you to try out more dimensionals if you want to. We have already covered the basic array structures, which were one-dimensional arrays. So I will just give you a quick walkthrough of how we actually handled one-dimensional arrays. So this is a sample program to demonstrate one-dimensional arrays. If you remember, this is how we used to create arrays. We write the data type of the array, and then we write the square boxes, which denote that this is an integer array data type. We assign a variable to this, and then we initialize the array with the size 4. So new is the keyword which is used to initialize anything in Java. And we are going to use this heavily when we talk about classes and objects and even collections. Literally any object which you want to create in Java requires a new keyword. So here I'm writing new and then int 4, which means create an array of size 4. And then I'm filling the value of the 4 positions which I have created as part of this array. And if you remember, when we create these kind of arrays, we store them in a zero index based position. The first value gets stored at 0th index position and then so on and so forth. So it will always start from 0 and never start from 1. Remember that. And after that, we just print all the values of individual positions of the elements in the array. And if I just run this program, all of the elements of this particular array should be printed one by one. So if I just show the full console of the output, we can see that element at index 0 was 10, element at index 1 was 20, element at index 2 was 30, and element at index 3 was 40. So this was just a quick refresher of how one-dimensional arrays can be written. And whenever you declare a very simplistic array, it will generally be a one-dimensional array. Now let's look at the two-dimensional arrays and how do we write them? When do we need them? For that, I have created another example, which is says two-dimensional array. I just created a class and it has a public static void main method. And I've created a two-dimensional array this time. So let's understand this two-dimensional array in a bit detail. And when do we need that? Generally, you would need to use two-dimensional arrays whenever you are trying to do any matrix calculations. If you understand what do you mean by matrix, it's basically a 2 by 2 structure which stores the values in the form of rows and columns. So imagine a table of 2 rows and 2 columns, then it will be a 2 by 2 matrix. So if you want to store that particular table in a Java program, you would need to store that as a matrix, as a two-dimensional matrix, rows being the one-dimensional and column being the other dimension. And that's what we are doing here. And if you want to store that 2D matrix in a Java program, the approach and the procedure for it is pretty similar to how you create a one-dimensional array with slight changes. The first change is instead of a single square bracket, you're going to write 2 square brackets because it is a two-dimensional array. So remember, the number of square brackets you are going to put while initializing and declaring the array is the number of dimensions which your array is going to have. Since this is a two-dimensional array example, that's why you see 2 brackets here. If this was a three-dimensional array example, you will see 3 square brackets here, and so on and so forth. So that's the first part of it. Second part to understand is to how to store the data. Remember, I told you always imagine the structure of rows and columns whenever you are trying to store a two-dimensional array in Java. So what are rows and what are values and how do you represent them while you declare and initialize a two-dimensional array? So you start with the curly braces as a normal 1D array, but inside the curly braces, you create nested curly braces blocks. You can see 3 blocks here. They start with their own curly brace and end with their own. Then this curly brace starts here and ends here. And then this curly brace starts here and ends here. Idea is that you provide this outer curly braces to define the overall structure. And then inside each of the curly braces is going to represent a row in your two-dimensional array. So each of these values, these blocks, is going to represent a row. So I can say that this is the first row, this is the second row, and this is the third row. And if I try to visualize it in terms of columns, then this is the first row, first column, first row, second column, first row, third column. Similarly, second row, first column, second row, second column, second row, third column, and third row, first column, third row, second column, and third row, third column. So individual values are going to be represented as columns, and the whole curly braces is going to be represented as arrays. That's the basic mental idea or mental image you should have while declaring a two-dimensional arrays. Remember to declare the rows inside the nested curly braces, and whatever elements you have will automatically be indexed as columns. Another thing to remember, that since this is an array data structure, everything starts from 0 and nothing starts from 1. So this will be row 0, this will be row 1, and this will be row 2. I'm talking about the position. We can still call it as first row, second row, and third row, but the position of this particular row element is 0. The position of this particular row element is 1, and this particular row element is 2. Similarly, for column as well, this is column 0, column 1, and column 2. Similarly, column 0, column 1, and column 2, and so on and so forth. Once you understand this data structure well and you have defined it correctly, then everything should fall in place. If you want to do a matrix addition, or if you want to do a matrix multiplication or a dot product, all of the kind of calculations can be performed using the 2D array concept. Here in this program, what I'm doing is I am printing the values of this particular 2D array into a matrix style. And you see some strange code here, which is for etc. Don't worry about this. I'm going to cover in detail what this for means and how do you write this. For now, what we can understand that we just want to print this. You might not need to print this in your Java programs when you write a production grade application, but you might want to do manipulations on these arrays as metrics. Maybe you want to create a transpose of a matrix, or you want to do a dot product or addition or subtraction or whatever be your use case. In this case, just for demonstration purpose, I'm printing the values as rows and columns, nothing else. So this all of this code from line 8 to line 14, or in fact line 13, is just showing how to print the values. You can see some system.out, and you can see some construct here. And like I said, don't worry about this. I will cover this in detail. Let's run this program and see if my Java array is stored correctly and how can I represent this. So you can see I have represented it in a style of a 2D matrix, where this is the first row, this is the second row, and this is the third row. Similarly, this is the first column containing the value 237. So column 0 will have value 2, and column 1 will have this value 3, and column 2 will have this value 7 for row 0. Let me also do something here which can help you understand this concept better. Let me do a system.out.println, and let's print an individual value, because like I said, the for loop can be confusing here to understand. So let's say I want to print ARR of 0th row, first column, and see what kind of values do we get. Let me comment this code. Comment is control backslash, and this code will be commented, and this code will not be executed. And now only line 15 will be executed instead of the for block. So if I run this, I get the value 7. So row 0 and first column, row 0, first column is 7. Let's try with 1, 1. I want to print the row at 1 position. Remember, not the first row, but the 1 position row, which is basically technically the second row. So second row, second column, and see what kind of value do I get in this case. I get 6. So second row, second column. Similarly, if you change this value to 2, then third row, second column, which should point to 4. Yes, we get 4. Similarly, you can write a value here as 0, and you can write a value here as, let's say, 2. This will print the 0th row and the second column. So similarly, whatever kind of value you want to write, you want to access, you can access it in this fashion. And remember, the column and row indexes will always start from 0. So this is a simple demonstration of how you can use two-dimensional arrays. And in this session, we also did a refresher of one-dimensional arrays. And in the next session, we are going to be discussing how we can define three-dimensional arrays, and we'll also see an example of it. So as you can see from this image, we talked about 1D array, which is having just one axis. Then we talked about 2D arrays in the last session, where we had rows and columns, basically an x-axis and a y-axis. And then we can also have a 3D array, which will have three axes, which will have an x-axis, a y-axis, and also a z-axis. Think of a simple box, which every box in this world will always have at least three dimensions. And from here, you can go even build more complex arrays, which can have 4 dimensions or 5 dimensions or as many dimensions as you want it to have. And today we are going to look at an example of how can we build a 3D array and how do we access those elements. But this picture is just to show you the mental model of when you will be creating a 3D array. So for example, generally an image data is stored in 3 dimensions. So you might want to store the image data into a 3D array. And there can be many other use cases in the mathematical and research computational use cases where you might want to use a 3D array. So, but remember, there's an x-axis, there's a y-axis, and then there is a third axis, which is called the z-axis. So let us look at a Java program to understand how we can build a 3-dimensional array. And for that, I have created this class, which is called multi-dimensional array. It has a entry point method, which is the public static void main method. And then I have created an integer array. And this time, instead of 1 or 2 square brackets, I have 3 square brackets. And if you remember, I mentioned this in the previous session as well. The number of square brackets which you're going to put while initializing the array is the number of dimensions of the array. And since in this particular program, I'm going to demonstrate a 3-dimensional array, that's why you see 3 square boxes. Let me just minimize this. Yep. So we have 3 square boxes here, and we have created the variable name as ARR, or short form as array. Then we start with the outermost curly braces as is. Then we put another curly braces which starts from here and it ends here. Then another set of curly brace which starts from here and end here. So this is the first dimension. This is the second dimensions, and these are the third dimensions. That's how you're going to define the different dimensions. Remember, this is the first dimension when the first curly brace starts. Then you have this second dimension which covers this hole and this hole, and then you have third dimension which are these. So that's how you're going to visualize and put the 3 dimensions in use while declaring a 3-dimensional array. And the values work in the same fashion. It's a 0 index based position. So since we do not have an official name for the third dimension, so I'm just going to use x-axis, y-axis, and z-axis to refer to the 3 axes. So this would be x of 0, this would be y of 0, and this would be z of 0. Similarly, x of 1, y of 1, and z of 1, and so on and so forth. So now if I try to access the value which is at 0th x position, first y position, and second z position, what's the value do we get here? Let's run this program and understand and interpret the output. Okay, so when we ran this program, we got the output as 11. So let's understand this output. So when we say the 0th position on x, the first position on y, and the second position on z. So this is the 0th position on x, and this is the first position on y, and then this element is 0, 1, 2 is the second position on the z-axis. So to describe it in a nutshell, this defines the x-axis. So we have 2 elements on the x-axis here, this one and this one. Then we have 2 elements on the y-axis on each x-axis. So this is 1, this is 2 on the first x-axis, and this is 1 and this is 2 on the second x-axis. So 2x and 2y, and then on the z-axis, I have 3 elements each. So hope this helps you understand and visualize this. So x-axis, and this one is other x-axis, and then y-axis, and then in elements inside this are z-axis. So I'm saying 0th x-axis in this block, first on the y-axis, which is this block, and then second element or the z or second position element on this particular axis in this particular block, which is 11. And that's why we get 11. If I print 0, let's say I change this particular value as 1. So now the output should be coming from this side. So second x position, because it's 1, second y position, so this will go here, and then the 2 position, which is the third element of the z axis, which is 13. So let's see if we get 13. Yes, we get 13 here. So this is just to show you how you can interpret this particular array, and always be mindful of how you are structuring this array. If your structure is gone wrong, then your program will become useless, and it will give you a lot of unpredictable outputs which might not make sense and which may introduce errors in your program. So be very careful how you define the structure of the elements here. That's the key. And after that, you just need to understand the x-axis, the y-axis, and the z-axis. Always remember all the axes start from 0. So when I say 2, I'm basically referring to the third element and not the second element. So this is all I wanted to cover in this particular session, where we describe how we can use a 3-dimensional array. And from here, you can go to any lengths. Like I said, you can add more square brackets here and go to 4-dimension or 5-dimension or 6-dimension. But remember, the more dimensions you add, the more complexity of the program will be having. The program will become more and more difficult to debug and understand. So always try to take a wise call as to how many dimensions you want to use in your array. And that's it for this particular session. In the next session, we are going to talk about the different loop statements in Java. Let me switch to the Java documentation, and if I can find some syntax of it as well. Yep. So as you can see here, if I just highlight this portion, this is how you actually write a do while statement block. So you write do, you start a code block, you write some executable statements, and then after the code block ends, you write a while expression and end it with semicolon. This is the syntax basically. It starts with do or curly braces, some executable statements, a while block or a while statement basically with an expression ending with a semicolon. Let's understand this with the help of a program to understand the structure better. So for this, I have created a sample program here, which is called do while demo. Again, having a public static void main method, and it has a variable which is count, and it is initialized as 1. Then I write do, I write this code block or the curly braces, and then I am just printing the value of count. Then I am incrementing the value of count, and then I am writing a condition which says while count is less than 10 and semicolon. If you compare this with the previous demo we ran, if I just put them side by side, we had while condition statement and the state change condition. Here we have do statement, condition change statement, and then we check the condition at the end. So the idea is that if you have a use case where before you even evaluate the condition, you want to print something, even before you evaluate the condition, if you want to do something, in that case, you will use the do while loop. Even before the actual while loop starts, if you want to execute a statement, you will use do while loop. For example, if you want to print the initial value of the count even before the condition checks, then you can use do while loop. If that is not your use case, you can use the simple while loop, which is described here in this program. So coming back to the do while, so I say do, and then I'm saying print this particular statement without checking anything. This condition will be executed for the first time without any condition check at all. This will just work as is, like a normal Java statement. After that, I'm incrementing the value of the count, and then I'm checking the condition. So remember, when this particular condition is being checked, the first increment has already happened. But in the while case, we did the comparison before even the first increment. The first comparison happened with the original value of count. But here, the first comparison is happening with the incremented value of the count. Hope you get the difference in a better context now, that you will use this when you want to write some initialization code before you actually hit the condition. So this condition will be evaluated with 2 less than 10, and then the value will be printed. Let's print this example, and we'll also try to play around with this example a bit more to build our understanding better. If I run this program, there is no difference in output if you compare this with the previous program we ran for the while. So it prints the count value. So this is coming here. Then it increments the value. Then it checks the condition saying is 2 less than 10. Yes, that holds true. If that holds true, it will go back to statement number 9, again print this, again do an increment on the count, and again check the condition with the updated value of the count, which will say 3 less than 10 now. Similarly, print the value, increment, check. This will continue to happen till this particular condition becomes false. And once this condition is false, it will exit out of this whole do while loop and it will go to the line number 12. And if you have any statement written there, you can that statement will be executed in this case. So let's try to change some values here and let's see if we can make sense of this program if we change the value. Let's say if I put 11 here, what will happen now? Let's run this program. You will say now you will see that this particular output is displayed which says count is 11. So what happened here, that count was 11, it entered the do while block, it went to this particular statement which said count is 11, then it incremented the value, so the value became 12, and obviously 12 is not less than 10, so it did not print it again. It only printed once, even if the first time the condition was checked, the first condition execution itself resulted in false. Still, line number 9 got successfully printed, and that's the whole idea behind using the do while. What if I change this value to 10? Let's see what happens. And after that, we'll run one more combination to just make it more interesting. This time again, count is 10. Line number 10 will be printed as count is 10. Then at line number 10, the count is incremented to 11, and 11 is not less than 10. So in this case, the loop ends and it will move out. Now, what happens if I do this? If I say less than equal to here, let's run this program and interpret the output. Now, again, only one statement is printed because in this case, the count is 10, 10 is printed here, and we are saying 10 plus 1, 11. 11 is still not less than equal to 10, and that's why the loop just exits. Let's make it 9 and see what happens. Now you see two values. So count is 9, it enters the do while loop, goes to statement number 9, prints the current value of count, which is 9, then increments the value to 10. Then at line number 11, this while statement is executed and the condition is checked. Is 10 less than equal to 10? Yes, 10 is not less than, but 10 is equal to 10. So this condition will hold true. It will go back here, print count is 10, make count 11, again check the condition, is 11 less than equal to 10? No, it's not. And then the condition will return to false and loop will be exited. So hope this will give you a better understanding now, since we ran different permutations and combinations of the values and we saw when this will be executed and when this will not be executed. But the bottom line is very straightforward, that whenever you want to write some pre-processing logic, even before checking the very first condition of your loop, then in that case, you will be using a do while loop. Otherwise, a normal while loop or a for loop will absolutely work fine. So that's the takeaway I would like you to take away from this particular session. And that's all for this particular session. We talked about do while, and we also tried to give you some sort of a comparison between while loops and do while loops. In the next session, we are going to be discussing about for loops in detail. So first of all, understand why do we need loop statements? So generally, whenever you are dealing with some data structures in Java, which can store multiple elements, for example, we saw array, which can store multiple elements. String is also basically technically a character array, which is storing multiple characters. So whenever you have these kind of data structures where you have multiple elements being stored in the same, then in that case, you would like to have a way to iterate or access all of the elements in a seamless fashion. One of the ways is to access them individually one by one, but that's too much of work. That's too much of code. There has to be a simpler way of accessing all the elements one by one if I want to. And that's where the majority of the use cases for using loops coming to picture. Now, Java provides multiple constructs to write loops in Java. There is a while loop, there is a do while loop, there is a for loop, there is also an enhanced for loop. And in the previous versions of Java, a use case of iterator was also very popular. So there are multiple ways in which you can actually iterate over a collection and access all the elements of the collection one by one. And you can use it to multiple useful cases. For example, if you have a huge array of employee salary and you want to give bonus to each of the employees and add the bonus to the salary, then you need to do this addition for all the employees. It would be nice to have to return a while loop, and the while loop can automatically access all the employee salary one by one and keep adding the bonus to the salary. This would be an easier way to do this rather than individually updating each employee's salary. And the first loop statement we are going to understand is a while loop. So the syntax of while loop is very straightforward. You write the while keyword, you enter the actual condition which will be evaluating to a Boolean true or false. So you write the expression which will be a Boolean expression, exactly similar to the conditions which you use to write in your if statements. So you write your condition which will evaluate to either true or false, and then you write your statement. And these statements will keep executing till the time this particular expression evaluates to true. So generally the way it works is that it will enter the while block, it will evaluate the expression. If the expression becomes true, then the statements inside this particular while block will be executed. And after the execution of the statement, it will again go back, again evaluate the expression. We call them steps basically. So it will go to the next step, again evaluate the expression. If this still holds true, it will again go inside, execute the statement, move on to the next step. It will again go to the evaluation. So this loop will continue to go till the time this condition will hold true. If it still doesn't make sense for you, don't worry, we will have a demo of it to make you understand how to use the while loops. And maybe it's a good idea to switch to the IDE and look at an example of it. So I have already created while demo for it. Here it is. It looks very small and simple, but it will get to the point where we can understand how and why will we be using the while loops. So I've created a while demo class. I've added a public static void main method here, which is the entry point. I have declared a variable which is int count equal to 1. So the count value is 1 right now. And then I'm writing a condition here. I'm saying while count is less than 10, do this. So it will print the current value of count. And after that, I'm using the post increment unary operator. If you remember, we covered this in the previous sessions. What is the meaning of this? It basically will increment the value of count by 1. This expression is equivalent to if I write it in this way. If I write count equal to count plus 1. This is exactly the same as this. No difference. So this will have the same impact. I will just remove this line because we already have the count plus plus here. So if we try to understand this, we are basically incrementing the count and then checking the condition again. So at first time, it will be 1 less than 10. Yes, that is true. It will go inside and print the count value, the current count value, which will be 1. And then it does count plus plus. So now the count value becomes 2. It will again go back here, again check the condition saying is 2 less than 10? Yes, that is true. So the while condition again becomes true. It will again go inside this, print the current value of count, which is 2, then do count plus plus. So it will again increment the value of count. So now the count value becomes 3. Again go back here at condition and saying is 3 less than 10? Yes, that is still true. Again come here, print the 3. Again go here, make count as 4. 4 less than 10, prints 4. Again count plus plus, count becomes 5, and so on and so forth. It will keep doing that till the value becomes 10. So at a step when count plus plus results in the count value being updated to 10, it will go here and say is 10 less than 10? Now that is not true because 10 is equal to 10, but 10 is not less than 10. So this condition will become false and it will exit of this while loop and it will come here and it will execute if there was anything written after the while loop that will be executed. So that's the idea, that you want to do something till a particular condition holds true. Then you can use the while loop, define your condition and execute the statements and try to do something which changes the state of this condition. Here I'm changing the count so that every time a new evaluation happens. If I comment this will result in an infinite loop because 1 will always be less than 10. I will not be incrementing the count here and it will keep running forever. It will never stop. It will just keep printing 1, 1, 1 every time till your computer program runs out of the memory. So always remember not to end up into an infinite loop. That's probably one of the biggest mistakes any beginner programmer does. So please try to be aware of that particular loophole, not try to run an infinite loop. Always try to write something in the code block which can change the state of the condition, and also make sure that that state condition sometime should become false. You should also make sure that that always becomes false, because if I do this, then this condition will always remain true, because it is already 1, then it will become 0, then it will become -1, -2, -3, so on and so forth. But that value of count will forever be less than 10. And again, you will never be able to exit this loop. Your program will be stuck in this loop till your program runs out of the memory. So always remember to write a statement or a statement of execution in your code block, which can change the state of the condition, which results in some eventual time when this condition becomes false. This condition has to become false eventually, otherwise you will never come out of the loop. Always remember that. So if we run this program now, let's observe the output. So we can see here this particular statement is printed for 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's it. After 9, the moment the count plus plus resulted into the count value becoming 10, it checked that condition and then it just came out of the loop because 10 is not less than 10 and the condition became false. So always do something inside your code block which results at least of one scenario where this condition becomes false. And that is how you can use the while loop. Now you can see this is a pretty generic code and you can write any kind of condition here, write any code you want to execute here, and then do something to change the state of the condition as well in a positive way, in a way which results this particular condition to be false at some point of time. And then your while loop will run fine. So this is all I wanted to cover in terms of the while loop. We have a lot of more exciting stuff coming in terms of different loops. But for this session, I think we'll stop here at the while loop understanding. And in the next session, we are going to understand how a do while loop works. So I have just opened the official Java docs here. So if you see, this is basically the syntax of a for loop statement. So let's understand it. And let's also try to compare it with a while loop so that we can understand how it compares with the while loop. So if we see the syntax, we first see the term initialization, then we see the term termination, and then we see the term called increment. Now, if I try to compare it with a while loop, there also you basically did these three things. You first initialized a variable outside the while loop, which is called initialization, and then you wrote a condition which is your termination condition. You wrote a condition saying, let's say, while I is greater than 10 or while I is less than 10. So that is the condition, which is also the termination statement. The loop will continue to execute till that condition evaluates to false, and that's when the loop terminates. That's why we call it as termination. And then the third piece of it is the increment, the I++, which we used to do in the while loops. So these three portions together make or constitute any kind of loop in any kind of programming language. And for loop, if you see, the kind of code which you use to write in a while loop in multiple lines, where you first initialize a variable, then you write a condition in the while block, and then inside the while block, you use to increment the variable. All of that can be done in a single line in the for loop. And that's why I said it is the most sophisticated and easiest way to write loops in Java. So you write all of these three things, the initialization, the condition, and the increment or decrement values in the single line. And then you start with the curly braces and you write the code which you want to keep executing till the condition evaluates to false. That's the basic syntax of it. So let us try to understand this with the help of an example. So here I have opened a class which is called for demo. And this is a class which will demonstrate the usage of a for loop. So again, we have a public static void main method, which you can see here, which is the entry point. And then I use the keyword for. I put standard braces or the brackets, and then I do the initialization. So this part is the initialization part. You initialize the variable. So I just say int I equal to 1, initialization done. You end it with a semicolon, so that it is a single statement understood by Java. And then you write this condition, which is your evaluation/termination condition. So this condition is basically the deciding factor of how long your loops should run. It's exactly similar to what you used to write in the while block. If I just show you the example, this is what we used to do. So we did the initialization at line number 7. Then we wrote this termination condition inside the while syntax or the construct. And then we did the increment here. So we are doing all of these 3 steps, but we are doing it in a single line. So this is the condition, and then we write our increment or decrement values, which are going to change the evaluation condition every time at every step. So we are saying I plus plus. So technically what I am saying here is that start with I equal to 1 and then check the condition I less than 10. So in the first step, it will be checking if 1 is less than 10. If the condition holds true, go inside the for loop, execute the statement at line number 7, and then go back to this particular statement. So we do I plus plus. So I becomes 2, and then you again go back to the condition. And again you check if 2 is less than 10. Yes, it is. So again you go inside the for loop and do whatever is written there. There can be multiple statements here. For now, I have just written one system.out.println. So that happens. And once all the execution is finished inside the block, it will again go back to the increment. Does the increment, so 2 plus 1 becomes 3. Again does the evaluation. And if the condition holds true, it will again go inside. So this will continue. This condition checking, execution, and increment will continue till the time this condition holds true. The moment this condition becomes false, the control will come out at line number 9. So that's the basic anatomy and control flow. It's very important to understand the control flow of a for loop. Otherwise, you might end up into a program which is forever running and which will just eat up all the memory available in your JVM. So be very sure of what you write in your for loop. Be very sure of especially these two parts, the condition and the increment or decrement. So this is very important piece. The initialization happens only once, and then this condition evaluates. If the condition holds to true, some code executes, goes back to the changing statement, which can be an increment, decrement, whatever, and again compares the updated value with the condition. So this will keep happening. Let's run this code to interpret the output. So I will right click, go to run as Java application. And if I interpret the output here, I can see that it started with count is 1, 2, 3, 4, 5, 6, 7, 8, and 9. It stopped at 9. So what happened there? Let's try to evaluate the termination condition. So let's say I has become 9 and 9 is less than 10. So it goes inside and it prints count is 9, which is I. Then it goes here and it says 9 plus 1. I plus plus means 9 plus 1, the current value of I plus 1. It becomes 10, and then it again compares the condition. So now 10 is not less than 10. 10 is equal to 10, but it is not less than 10. So the condition becomes false, and count is 10 is never printed because this condition has become false. It will jump out. So let's say if I do this, if I put an equal to here, and if I now execute the same program, this time I will see 10 here. And because I have said that, okay, check the condition, if 10 is less than equal to 10, that will become true. It will print count is 10. Then it will increment and the count will become 11. The I will become 11. And then it will check 11 is less than equal to 10. No, it is not. So condition becomes false and the control comes out of the loop. So that's how you should always try to interpret the loops. You can also run some infinite loops. For example, if I say I equal to 1, I leave it that, and I say I minus minus. So what happens? I equal to 1, 1 is less than 10. Yes, it goes here, prints the value, and then I decrement the value. I don't increment the value, I decrement the value. So whatever value comes out will always be less than 10, and this loop will run forever. For fun, let's try to run this, and I will have to kill this program manually, but just to show you what happens and what you should not do in your Java program. So you see, it will continuously keep printing the values till the program runs out of memory, till it eats up all the available memory. It is forever running. It will never stop because the condition will never evaluate to false. This condition will forever be true. So the loop will run forever. So I'm just going to kill the program, but this is something which you should avoid whenever you are writing Java code. And this happens quite often with beginner programmers. So this is all I wanted to cover in today's session. we talked in detail about the for loop. And in the next session, we are going to talk about another interesting way of writing for loops, which is also called enhanced for loops. We generally use the enhanced for loops for scenarios whenever we have to iterate over a collection of items or an array of items. Those are the most popular and common use cases of using enhanced for loop. And this for loop is even simpler. Like I said, it's even simpler than writing a classic for loop. And the syntax is simply like this. You again start with for, put the standard brackets, and then let's start from the rightmost, because then I will be able to explain it better. You specify the collection in the rightmost side of the bracket. The collection can be an array, it can be a list, it can be a map. So whatever different kind of collections which are available in Java, and we are going to cover collections in detail. So don't worry if you don't understand what are lists and what are maps and what are sets. We will go into detail of each of these one by one in the upcoming sessions. But the idea is that you put the collection to the rightmost, then you put a colon, and then you put a representation of the member of this collection. So for example, here this numbers is basically an int array. So this int array means that this array can only hold integer numbers, and that's why we write int here, because this array is only having integers. Then we put any placeholder variable name. This can be anything. You can even write it as I if you want to. You can write it as anything, any variable name which you want to write. This is a temporary variable. So now this code is going to execute in a manner that it is going to iterate over this array one by one, starting from the first element, going till the last element. You don't need to write any initialization code. You don't need to write any termination condition code, and you don't need to write any increment or decrement code also. And how these three values are actually taken care of, let's understand that as well. So when we talk about the initialization, as I have put an array here, a data structure here, the automatic initialization index is going to be the first index. So when we do the iteration, when this for loop is going to execute, it is automatically going to initialize a temporary variable with the value at the first index, which is the index 0. As you know, that array is a 0 index based structure. Then comes the condition part. So the condition evaluation is going to be again based on the size of the array or the size of the data structure which you are using. It is going to start from the first index, which is the index 0, and it is going to iterate till the array's last element is reached. So technically start from the index 0 and go till the last element. That's your evaluation condition. And then comes the increment part. So at each step after it has successfully accessed the first element, automatically the index is going to be updated to pointing to the next element. So if it starts from here, once the first step iteration is complete, I is automatically going to be incremented to index 1, and then it will basically, this I will be holding 2. Then in the next iteration, the same I is going to be holding 3. Similarly, I will keep holding the new value of the collection item one by one till the collection item's last element is reached. So this is the basic premise, that you can write a collection variable here and keep iterating over it, and this whatever variable you write here will hold the current item's value one by one. So in the first step, this I is going to hold 1. In the second step, this I is going to hold 2. In the third step, this I is going to hold 3, and so on and so forth. That's the basic idea. So now let's run this program to see what kind of output do we get. So you can see we basically are able to print all the elements of the array. And that's probably one of the most popular usage as well, that if you want to just print all the elements or access all the elements of a array or a collection one by one, then just use enhanced for loop. So you can see at each step, it is printing the value of I, and the value of I is basically the subsequent elements of the array. That's the whole idea with enhanced for loop. Under the hoods, if we talk about how does it work under the hood, it is actually using the classic for loop construct itself. But for developers, it is making it easier because it knows that if you are iterating over a collection, you will start with the first element and you will go till the last element. So it knows the initialization value, the termination condition, and it also knows the increment condition. And that's the reason you will use enhanced for loops in Java for iterating over collections. Now there is another advanced concept in the for loops, which is around nested loops, but I think it will be too much complicated if I talk about this in this particular session itself. So we are going to restrict this session to only discuss about enhanced for loops. And in the next session, we will be talking about the nested for loops concept, and we will be looking at an example of how to implement nested for loops and when do we use nested for loops. So in front of you, you can see an example which I have prepared for nested for loops. And in this particular example, I have created a two-dimensional array. As you can see on the line number 6, I have created an integer array and I have put two square brackets here, which are basically symbolizing that this is a two-dimensional array. So this two-dimensional array is going to hold technically a 2D matrix. And we are going to use the concept of nested for loops to print this 2D array in a 2D matrix style where you will be able to see the rows and columns clearly. Let's first try to interpret this particular 2D array. So we have a curly braces outside, and then we have these three inner elements, which symbolizes three rows basically. So this is the first row, this is the second row, and this is the third row. And then each of the rows have three elements each, which symbolizes the column values or the item values. So it's basically a 3 into 3 2D array, which has three rows and three columns. So we can say that this is basically a 3 into 3 array, which has 3 dimensions on the row side and 3 dimensions on the column side, or just a 3 by 3 matrix or 3 by 3 2D array. So as we know that in case of arrays, everything starts from 0. So technically, if we talk about the indexes, it would be the index 0, index 1, and index 2 on the row side, and similarly index 0, index 1, and index 2 on the column side. So that's something which you should remember, because we are going to use this particular concept when we write the for loop. So let's try to write the for loop now. If you look at line number 8, we put this keyword called for, and then we write the initialization. So we say int I equal to 0. Then we are writing the termination condition, and we are saying run this particular loop, run this whole loop which ends at line 13 till I is less than 3, and keep incrementing I at every step. That's what I'm doing in the line number 8. Then inside the for loop, I'm writing another for loop which has another different variable called j. It can be anything, you can name it anything you want. And this also starts with 0. And this also has a similar condition which says run this particular loop, the line 10 basically, or this loop which is signified by this curly braces, run this particular loop till the time the value of j is less than 3, and keep incrementing j at every step. And at line number 10, print the element of array which has the current value of I and the current value of j. These are basically the positions. These are not the elements. The element would be represented by this whole, but print the element which is at current I and j's position values. That's what this code means. So let's try to do a dry run on this particular code to understand how this is going to work. So at first we have I equal to 0. 0 is less than 3, and it goes inside. It initializes j as well with 0, and 0 is also less than 3. So this condition went true. That's why we went to line number 9, and line number 9 condition also went to true. So we went to line number 10. Remember that in this particular case at line number 10, the values of I and j are 0 and 0 respectively. And we are saying print the array of 0 and 0. So 0th rows, 0th column element should be printed. So this is the 0th row because this is the first subblock, and this is the first element. So in this case, in line number 10, 2 should get printed. Then it goes here and it increments the j to 1. So 0 plus 1 becomes 1. It again checks the condition, is 1 less than 3? So yes, 1 is less than 3. it goes here. Remember, it did not go up at line number 8. It just came back from line number 9. So when it comes here, I is still 0, but j has moved from 0 to 1. So now we are trying to access the element which is at 0th row, first column, which is going to be 7. So 7 is going to get printed. Similarly, on the next iteration, j is going to get incremented from 1 to 2. And again, the condition will be evaluated. So 2 is less than 3. All good. It will again come back to line number 10. And now it will say print the value of 0 row, third or the second column or the third element. So 0th row, third element, which is the 9. So 9 will get printed. Then again j will be incremented and j will become 3. 2 plus 1, 3. And now the condition will be evaluated. Is 3 less than 3? No, it is not less than 3. The condition becomes false. So it breaks out of the loop, goes to line number 12, prints an empty line because we are not writing anything here. So it will just print a blank line. And now it will go back to line number 8's condition and it will do an increment of I. And now I will move from 0 to 1. And now the evaluation will happen. Is 1 less than 3? Yes, 1 is less than 3. So it will again go to line number 9. Again, initialize j with a fresh 0. The previous j got destroyed the moment you came out of the loop. So this is a new j. So this j again gets initialized to 0. 0 is less than 3. It goes here. Remember, I was 1 in this time. So now it will print the value of this 2D array, which is sitting at 1, 0. Basically, second row, first element. So second row, first element, which is 3. Again, j is going to get incremented and it will become from 0 to 1. So 1 is less than 3. Yes, it will again come here and it will print the value of the array, which is sitting at array of 1, 1 for a row equal to 1 and column equal to 1, which will be 6. Similarly, j will get incremented again. Again, 2 is less than 3. Come back here, we'll print 1. Then again, we'll increment j. J will become 3. 3 is less than 3. No, it's false. The condition is false. So it jumps out of the loop, goes to line number 12, prints a blank line, again goes back to 8, line number 8, increments I, and I now becomes 2. 2 is less than 3. Yes, it will again go here, initialize j again with 0, and again does the same thing for the row 2 and column 0, 1, 2. And again, it will come out of the loop. This time, again, when it will go here, the value will become from 2 to 3, and 3 is not less than 3. So then it will break out of the outer loop. So the idea is execute the inner loop for every value of the outer loop. Remember this line because that is how you will be applying your knowledge of nested for loops to be used in certain condition. So whenever you have a scenario where you have to iterate over a collection based on a certain value of another collection, then you can use nested for loops. Or you have a scenario where you have to iterate over 2D or 3D arrays. For example, if we were dealing with 3D arrays, then you would have seen 3 nested for loops here, and where it will apply the same logic that iterate over all the collections, all the values of the inner loop on a particular value of the outer loop. Then increment the value of the outer loop and do the same thing again. Iterate over all the values of the inner loop based on a fixed value of the outer loop. So let's run this program and let's see what kind of output do we get. So like I said, our motive, our target was to print this in a matrix style. And you can see that it is printing in a sort of a matrix representation. So the first row gets printed here, then the second row gets printed here, and then the third row gets printed here. If you try to decipher it, it will work exactly the same way as I explained. So I equal to 0, 0 less than 3, condition becomes true, comes here, j equal to 0, j less than 3, condition becomes true, comes here, prints the array of 0, 0, which is 2, then prints the array of 0, 1, which is 7, 0, 2, which is 9, then j becomes 3, it breaks out of the loop, goes up here, I becomes from 0 to 1, 1 is less than 3, yes, again comes here, reinitializes a fresh for loop with a new j setting to 0, and it will print the array of 1, 0, 1, 1, 1, 2, then similarly array of 2, 0, 2, 1, 2, 2. So that's basically what we are doing. We are picking the first row and iterating all elements of it, picking the second row, iterating all elements over it, and so on and so forth. You can do this for any n-dimensional kind of array or a collection. So this is all I wanted to cover in today's session, where we discussed about the nested for loops concept and how and where we will use it. Let's get started with walking through a core Java project using all the different OOPS concept we have learned so far. So in this example, we are going to have a look at a calculator application. And this calculator application supports primarily 4 different operations like addition, subtraction, multiplication, and division. So let's see how do we build that app. So in front of me right now is open the main class. So I have a main app class here, which has a public static void main method. And the first thing we see is a read input class, which is calling a read method. So if you go to the read input class, it has a simple static method here, which is the read method, and it is using the scanner class. If you remember, I talked about the scanner class, which is used to take inputs from the command line from the user. So we initialize the scanner class and we start taking the inputs, and whatever the user inputs in terms of the expression, let's say the user entered 4 plus 5 or whatever, that whole expression gets sent back into this input line as a string. And that comes back here in the input expression. Once we have captured the input expression, the next thing we do is divide the input expression in the numbers and the operators. Basically, an expression would be either something like 4 plus 5 into 3 divided by 2, let's say. Let's say the user entered this expression. So this has either numbers or operators. So that's what we are doing here. We are using the split method of the string API, the string class basically. And this split method is going to split the numbers and operators into 2 different string arrays. And here I'm providing the split expression that split at every time you encounter one of these symbols. So this, when you execute this particular statement, it is going to return a numbers array, which will be created based on this expression. So you will get an array with 4, 5, 3, and 2. And similarly, in the operator array, you are going to split or pick out the elements every time you receive a number. So this operator array is going to hold this plus sign, this multiply sign, and this divide sign. Hope you get the understanding that we are just splitting the whole expression into 2 different arrays, where first array is holding only the numbers and no mathematical expressions, and second array is just holding the mathematical operators and no numbers. And we'll see why we need to do that in the upcoming lines. Once I've created this string array, I just want to store or convert these string arrays into a queue. So I convert this array into a list by calling the array.asList. So this expression is going to return a list. And then I'm going to convert this normal list into a linked list, and then going to store this linked list into the queue of numbers. And I'm going to do exactly the same thing for the operator array as well, converting this into a generic list, converting that generic list into a linked list, and then storing this linked list as a queue. So I have an operators queue and I have a numbers queue. Both of them have been stored into a queue now. And then I'm using the poll method. If you remember, the poll method of the queue is used when you want to fetch the first front element, the head element of the queue. So whichever element is sitting at the head of the queue will be taken out the moment you call the poll method. So I fetch the first number from the numbers queue. So in this case, 4 will be fetched here in this variable. And after that, I run a loop on the numbers queue. And I'm going to run this particular loop till this particular queue is not empty. If you see, there's a negation here. So I'm going to pick up numbers one by one from this numbers queue till the number queue becomes empty. And inside the loop, I do the exact same poll operation for the operations queue. So this operations queue is holding all these mathematical operations like plus, star, and divide. So I'm going to pick the head of it So in this case, plus will be picked up and will be stored in this variable called OPR. And then I'm going to run a switch case on this OPR. Basically, as I told you, in this particular calculator application, we are supporting 4 operations, which are addition, subtraction, multiplication, and division. So I define a case for each of the mathematical expression. So you see there are 4 different cases here. And for each case, I'm initializing a class. If it's a plus sign, then I'm initializing the add class. If it's a minus sign, then I'm initializing the subtract class. For multiplication, I have a class called multiply. And for division, I have a class called divide. Let's have a look at what these classes are containing. So if I go to the add class, first of all, it is implementing an interface called operate. And this operate interface has just a single method called getResults, which is accepting a variable argument array. If you remember, I told you that you can also use a var_arg array. This is called a var_arg expression. This means that this numbers will be an array of arbitrary length. It can be a 1-element array, it can be a 2-element array, it can be a 4-element array, or whatever you supply. But it is still going to be a fixed length array, but the length is going to be dependent upon how much argument you supply to this particular method. So that is what this interface operate is doing. It just has one method declared, which is called getResult, which is accepting an array of numbers. So if the add class is implementing the operate interface, then it has to override the getResult method. And here it is just doing a summation of all the numbers which have been supplied. So if you supply 4 numbers, it is just going to add up those 4 numbers and return the sum. And the exact same kind of logic or similar logic will be seen in other operate classes. So if I go to the subtract class, it runs the exact same operation, but it subtracts the values. If I go to the multiply class, it is also implementing the operate interface, and in the get result, it is just multiplying all the values. Similarly, in the divide class, it is also implementing the operate interface, and it is dividing all the numbers one by one. So it's doing pretty much the same thing in terms of the expression and the logic. The only difference is whether you are using an add operation or a subtract or a multiply or a divide. So we have checked all these classes and the operate interface as well. And let's go back to the main app now. Now you also see that I've defined a reference of operate here, and each of the switch case block, I'm assigning the object type to this. So once we have filled that based on the case, while filtering out this expression and picking up plus, star, and divide sequentially, then we go to the next line outside the switch case block, which is to pick the next number from the queue. Remember, we already did one poll here. So as per this example, 4 was here in this res. And now when we do this number.poll again, 5 will be picked up because that will be the next head of the queue. So we pick up 5 here, and then we call operate.getResult. Now this getResult will be called based on the expression which was encountered first in the queue. Again, looking at the example, the first expression encountered will be plus. So the expression was plus. So the operate type object is of add type. And when you call operate.getResult, the getResult method of add class is going to get invoked, and it is going to sum 4 and 5. This res is holding 4 right now based on what I described here, numbers.poll. And this num is holding the second operand, basically 5 here. So 4 plus 5 gets evaluated here in this case. And then it again goes back here and it checks if the number queue is now empty. No, it is still not empty because we still have 3 and 2 left there. So again, it does the operations.poll and it picks up multiply sign here. Then it again runs the switch case. Since it's a multiply sign, it will go here and it will initialize the operate interface reference as the object of multiply class. Then coming here, it will do a numbers.poll, and this time the numbers.poll is going to pick up 3. So 3 will be picked up here, and then the current value of result, which is already 9, 4 plus 5 was 9, the current value of result will be updated here. So res will be 9 here and num will be 3 here. And when you call operate.getResult, the multiply classes getResult will get called and it will say 9 into 3, which will become 27. It will again go back here to this particular line and it will check again if the numbers queue is now empty. No, it is still not empty because we still have one element left. Then it polls the queue of the operations where the expression divide is present there, which is the only element left in this particular operations queue. And since we have the OPR value as divide, this case block gets called and the new divide class gets initialized. The divide class basically gets initialized. And we come here and we do numbers.poll. Now the last number which is available in this queue is 2, which gets picked up here. And then we again call operate.getResult. This time, since the operate operate reference type was of divide class type, so when we call operate.getResult, the divide operation or the getResult method of the divide class, basically this method will get invoked and it will divide the current value of result, which was 4 plus 5, 9 into 3, which was 27. So it is going to divide 27 by 2, which was the last value of the numbers.poll. It is going to execute 27 by 2, and whatever value it gets, it is going to store a value back into the rest variable. And then it is again going to go back here and again going to check the condition if the numbers queue is not empty. But now the numbers queue is empty because 2 was the last element. So it is going to come out of the loop and it is going to print the final result. That is how this whole program is working. Now let's try to see this in action and we'll try to execute the exact same expression. So if I right click and go to run as and run this as Java application, and I supply an expression saying 4 plus 5 star 3 divide 2. And if I now hit enter, I get the value as 13.5, which is exactly what we ran through because 4 plus 5 will be evaluated first, which will result into 9. Then 9 into 3 will be 27 and 27 divided by 2 will be 13.5 exactly. So this is how this whole program is running, where we first take the inputs and then we divide the input into numbers and operation arrays, or in fact queues. And once we have those queues built up, then we pick up the first number and we keep running this loop till the numbers queue is not empty. Inside the while loop, at each step, we pick up the first expression or the operator. We check what is the operator, whether it is an addition, subtraction, multiplication, or division operator. And whatever kind of operator we have, we initialize the corresponding class of it. And then we fetch the next value in the numbers queue. And then we call the get result based on the expression. And whatever result we get from the get result, we store it back into the rest variable. So we keep updating the rest variable at every step. So that's the reason the result of 4 plus 5 gets stored in the rest. And next time you are calling the get result for a multiply operation, here the rest value is 9 now, and it says 9 into 3. Again, in the next time, the rest value will be updated to 27 because we are storing the result back into the result variable. So this is all I want to cover in this particular session, where we looked at an example of a calculator application purely from the console standpoint. Obviously, there can be a lot more stuff which we can do into this particular application, make it more error-free and cover a lot of corner cases like validating the inputs, etc. Also, looking at putting some conditions around the exception handling the divide by zero scenario, etc., which is not here. But this is just to show you the basic idea of how you can build simple to complex CLI applications using the core Java concepts.
And with that, we have come to an end of this full course tutorial. I hope it was informative and interesting. If you have any question about the topics covered in this video, feel free to put them in the comments section. Our team will help you solve your queries. Thank you for watching, keep coding, and stay tuned to SimpliCode.